What's up, notJust developers? Welcome back to a new live stream, and today I have prepared something exciting for you. Today we're gonna build a full stack Spotify clone by integrating directly with the Spotify API. In the end, by the end of this video, this is exactly the application that you're gonna have. On the home screen, we're gonna see a list of recommended songs based on the recommendation algorithm of Spotify, and from here you'll be able to select them, and they will play right away here at the bottom in the playlist. On the search screen, you're going to be able to search for the tracks that you like. You're going to be able to play from here as well. And another feature that we're going to implement is creating your personalized lists. For example, if you like a song, you can press on this icon and they will be added automatically to your favorites list. So yeah, that's the application that we're gonna build. It's a great start for building a music application, and you're gonna learn a lot today when it comes to building these kind of apps. Yeah, this is a great tutorial for every developer, no matter what experience you have, because for beginners, this is gonna be possible to follow along because I prepared the step-by-step guide, which I'm gonna share with you in a moment, and I try to explain everything that we are doing step by step. For more advanced developers, there is a ton of new stuff that we are introducing in this application, so I'm pretty sure you're gonna have something new to learn as well. So make sure to follow along and let's build this application together. What exactly you're gonna learn by the end of this tutorial is we're gonna start by implementing the React Native application using Expo and Expo router. After that, we're gonna see how we can create different components, how we can put them together to render beautiful user interfaces, and then we're gonna work on the music player. The player that you see here at the bottom of the screen, that is visible on every screen of our application, and also has various features of actually playing music, because that's the whole point of the Spotify application. We're gonna look how we can work with audio, with Expo AV, and yeah, that's our front-end side. After that, on the back end, which is also in today's video by the end, we're gonna integrate directly with Spotify API. However, Spotify API is a REST API, so in front-end applications, I really like working with GraphQL APIs, so that's why we are going to, where is my diagram? We're going to create a very thin layer of a GraphQL API that will connect with the Spotify API, and from our React Native application, we're gonna simply query the GraphQL API using Apollo client. So this might sound a bit confusing, but you're gonna see how easy it is because of the tools that we're gonna use. And for the GraphQL API, exactly, we're gonna use StepZen, which happens to be the sponsor of today's video. And thank you very much, StepZen, for supporting our channel and making these tutorials possible. StepZen will help us build the GraphQL pretty easily based on the pre-existing REST API from Spotify. And also we're gonna be able to connect to the same GraphQL API different data sources. We're gonna also work with a Postgres SQL database to save custom information about playlists that people want to build. So everything is going to be created using StepZen, and we're gonna also deploy it there, which is really scalable and optimized for GraphQL servers. Anyway, more details we're gonna see today, and I think we are actually ready to get started. So let's roll the intro and let's get started. All right, hello everyone who is joining us live. I really missed our usual Friday tutorials. During August we had a community challenge, but yeah, I'm ready to get back. We have a lot of tutorials prepared for you, and specifically this one with Spotify is really, really exciting. Before we get started, make sure to check in the video description below the URL for the step-by-step guide. I put a lot of work into these guides in order for you to easily follow along, like with all the commands that you have to run, with all the screenshots, explanation, and so on. So it's really gonna help you move along together with me. The next step would be to download the asset bundle, which you can find also here on the website or in the video description. Just follow along, leave your email, and you're gonna receive the assets that you're gonna need throughout this tutorial. I prepared some dummy data that will help you get started and some files with some types that will also help you. Anyway, as I said, we have a lot of things to do today, and I think we should get started in order to manage everything. We're gonna do both UI and backend. So yeah, let's jump into our first part, which is going to be our mobile application. For that, we're gonna use React Native with Expo. And yeah, I think we can get actually started with that. We're gonna start by initializing our Expo application, but first of all, let me put this one here. I'm gonna close this demo application, and we can go ahead and open a terminal to start with our initializing our Expo application. Recently, all my new projects, my React Native projects, I'm using Expo because that's really easy to get started. You only need notJust and npm to be installed. So if you have npm, that's the only requirement in terms of environment, and then you can follow together with me. So let's go ahead and do npx create expo app. I'm gonna also provide at latest to take the latest version of create expo application, and here let's give a name Spotify clone, and finally -t in order to choose a template and not start from completely scratch. I want to choose move the arrow down until we see navigation, and this is going to initialize our project using Expo router. Expo router will be configured, and it will have a couple of predefined screens, so it's going to be easier for us to get started. Let's go ahead and choose that template and wait for npm to install and bootstrap our newly created React Native application. How many hours you think? That's a very good question. I always say 2-3 hours. This one probably is going to be around 4 hours. I'm going to try my best to do it in 4 hours, but at the same time, there are also some additional features that I'm pretty sure you'll want to see. So we will see. Let's go till the end, and maybe at the end we're going to add like some extra features, such as the player with some animations. I don't know. I don't want to promise that. What I'm pretty sure we're gonna do is already said. So let's focus on that, on the fundamentals, and yeah, it's gonna be fun. Can we just use the Spotify API directly without using StepZen or whatever? You could do that. The only difference is the way you're gonna fetch it. Spotify API is a REST API, so you're gonna have to fetch it differently. The problem, like why I always try to use GraphQL APIs in my application is the benefit of easier fetching the right data that you need. And here in Spotify, if you open up Spotify, you're gonna see that the home screen has so many types of widgets, like popular songs, popular playlists, recommended based on a track, recommended, and so on. So all of this data, all of these widgets requires data from different parts of the API. For example, having like popular playlist that will also display the name of the tracks will require a couple of queries towards the REST API to first get the playlists, then get the details about songs in the playlist. So it adds up. With GraphQL, we simply create these queries that will aggregate the data that we need specifically for that place in our application, and everything is manageable from the front end. It gives more control over the data that you request, and it decouples. It allows us to work better as a separate like backend and front end. But anyway, I'm going to show you later what I exactly mean by that, and you're going to see the benefit of that. Does Spotify API provide audio to the songs? They provide 30 seconds previews, not to all songs, but to some songs. So we're going to use that 30 seconds preview. Okay, so let's go ahead. I see that the application has been initialized. I'm gonna open it using Visual Studio Code. Let's do it here. Let's zoom in a bit and let's go ahead and open a terminal right away to start our newly created application. To do that, I'm gonna run npm start. That will start the Metro server. I see that I already have one open. Yeah, I think I will start it on simply a different port. And after you see this QR code, what you can do is you can download the Expo Go application on your physical device and scan the QR code and you're good to go. If you want to work with emulators, simulators, for that you would need extra steps to set up Android Studio for Android emulator or Xcode for iOS simulator. But that's optional, so just for you to know. Now I'm gonna press I to run the application on my iOS simulator. It will take some time for the first build, and after that we're gonna see it here on the right. Hello Rogelio, hello Ferry, thank you very much. I would use Supabase more if I were you. I used Supabase in the last project during summer startup, and I really enjoyed it. Okay, so here we have our application. We have two tabs. This is the application that was initialized for us. Simple application with two tabs and a model here. If we look at the file structure, we will see what do we have. First of all, I want you to pay attention at the app directory. The app directory is specific to the Expo router, and that's where we keep all the screens. Expo router is a file-based navigation system, so by simply creating files here, we create screens. So it's quite simple to add new screens, for example, to our tabs. The tabs contains this tab 2 and the index. And if I would simply duplicate tab 2 and rename it to maybe favorites, because that's another screen that we're gonna need, we see a new tab automatically added to our bottom tab navigation. It doesn't have a proper icon at this moment, but we're gonna fix it very soon. If you're interested in Expo router, I think I have a dedicated tutorial about Expo router on our channel, and also I'm gonna help you like throughout this tutorial to showcase like how it works. What we want to do right now is clean up a little bit this template. And the first thing that I want to do is I prefer to keep all the source code in the src directory. So for that, I'm gonna create this directory here, src for the source, and I'm gonna move, first of all, the application directory. Move, then update imports, yes. Then the components also to the source, move, constants, move to the source. And that's it. I'm gonna leave assets here. So at this moment, our source should have app, components, and constants. We're gonna see that there is an error here, but we're gonna restart the server in a moment. Actually, let's do it right now. We will have to stop the server and start it again for Expo router to look into the new application folder. We change the location, so it needs to restart. Let's press I to rerun it on iOS. And we see an error with a file path. That is coming from source application layout. And here you will see that there is a file path that imports a font from assets. The problem is that we moved a bit the files around, so we have to add another pair of // in front of it to properly link to that font. Now if I press reload, hope everything is going to be back to normal. Yes, everything is back to normal. Perfect. Now everything when it comes to the source code is going to live in our source here. And let's see, based on our guide, what else do we want to do in the cleaning up the template process. We moved the components there, we fixed the imports. Let's copy paste the types.ts file from the asset bundle. In order for us not to have to write them. I prepared it for you, so give me just 1 second to find them. You're gonna download them from the link in the description below at asset bundle. And oh, come on, YouTube live streams. This is actually the 45th project that we are doing here. So here we have an asset bundle, and what you're gonna see here is the types.ts file. Let's drag this in our source folder. And I think it's also time to drag this data folder inside our assets. So the data, we drag it under our assets. And that's everything that we need right now. If we look in the types.ts, here I define a couple of types based on the data structure from Spotify API. For example, a track has a name, it has a preview URL, and information about album and artists. The same for the album, it has some images, name, artist as well. So pretty basic, but it's going to help us properly type the request and the data that we pass around. Okay, let's close the types for now. And in the data, we're gonna talk about the data in a moment. Yeah, so our next steps are going to be, let's go ahead and while we're still setting everything up, let's open our application tabs layout, and a layout file in Expo Router is helping us manage, first of all, the navigator, for example, the stack navigator or the bottom tabs navigator, and also everything else that has to be shared amongst all the screens in that group. And one good example of this is a provider. A data provider is usually something that you want to be shared among all the screens in your application. So we're gonna see that also in a moment. But here, for example, from source, up, tabs, layout is where we can configure and set up our tabs navigator. For example, if we scroll down a bit and we look at this title, tab 1, and if we change this to home, we're gonna see that at the top of the screen, the name of the screen has changed to home. The same thing with the tab bar icon. If we change the name of this tab bar icon to home, it's gonna be a home icon in the tabs. Let's go to the next one, and here for the tab 2, we're gonna have search, but in fact, instead of changing the title, I will do header shown false in order to hide the header. You're gonna see why we hide the header on the search page. It's because we're gonna have a search bar at the top. For the icon, it's gonna be search, and the search icon has been updated. What we can do is also rename the name of a file. Instead of to, I want to call it search. If we do that, we see that we lost the icon. Why? Because back in our layout file, the way we are linking options and configurations to actual screens is using this name. And the name should match the name of a file. So because we changed the name of a file to search, we're gonna target it using the name search. And we have an icon back here. Same goes for our favorite screen. If we look at the moment, we do not have a tab screen with the name search. And that's okay, because if it doesn't have here, it will simply use the default configurations. But if we want to adjust it somehow, for example, changing the title to favorites with capital F, we're gonna copy this tab screen one more time, and by targeting with a name the file with this name, favorites, and we're gonna specify favorites, I'm gonna have a header, so I'm gonna remove this header shown, and the name of the icon is going to be heart. Okay, just like that, we have 3 tabs with a proper configuration and with a proper fonts, with icons. The only thing is that I think the icon should be a little bit smaller, so if we scroll up until the tab bar icon, we're gonna see the size 28. We can decrease it probably to 22 and it will still look okay. Even 20? Maybe 22 is nice. Okay. Okay, we have the navigation. We have a navigation, we have everything. Probably the last step is to go into the index.tsx. This is our home screen, and remove the components that are being rendered here that we don't need. So let's remove them from here, leave only the container. I don't even need the styles here, and as you can see, the edit screen info is already not used. So now the home screen is blank, and you can do the same for other screens, but probably I will not bore you to do the cleaning right now. We can do that a little bit later. Let's go ahead and because we are finished with the setting up and cleaning, let's add a commit to have basically a checkpoint to be able to go back if something bad happens. Initialize and clean the template. Okay, perfect. The types is missing and the asset link is for the LinkedIn project. Is it in this asset bundle? Oh, okay. So what you have to do is go to assets/Spotify-2. But I'm going to actually update it real quick. Spotify content. Yeah, it's... Where is the URL? Here it is, and it should be updated. Here, and some notJust magic, it should, not yet, 1 2 3 4 5 6 7 10, every 10 seconds it should update. Yes, now it's updated, so you can download it from here. This is full stack application. Yes, this is a full stack application. We're gonna do both the front end and integrate it with a back end, add some custom functionalities. What themes are you using for your VS Code? I have a video on the channel with my VS Code setup. I think the theme is called Material Darker or Community Material, something like that. Are you standing or sitting? I'm standing, and I can also dance. But we need some music, so let's get back to our Spotify clone to be able to play some music to dance. All right, so back to our guide. Yeah, that's our tabs. We already implemented that. And the next step is our home screen. The home screen will render a list of recommended tracks. I'm gonna zoom out a bit for you to see the whole screenshot here. So yeah, basically it's a flat list of songs. Every song component is quite minimalistic and simple. At the same time, it has an image, the title of the song, the name of the song, and the name of the artist. Let's go ahead and start working on this. So the screen, the home screen, is our source app tabs index. This is the home, and at the moment it's empty. What we want to do first is to import the dummy data. I'm gonna first import tracks from one directory up, one directory up, one directory up, assets, data, tracks. And if we look into this assets, data, tracks, which we imported from the asset bundle, you're gonna see that this is an array of actual tracks. This data, I downloaded it from a request to Spotify API for us to focus first on the UI and not care about integrating with an API. And later on, we're gonna simply replace the way we take this data. So let's use it to help us get started. As we can see, it has all of this information about the name of the track, the preview URL, information about artists, album, and so on. So whenever something is not working on or you don't see the expected information, come back here and make sure that you are accessing the property the correct way. For example, the artist here is not an object, it's an array, because a track can have multiple artists. Anyway, let's take it here. So now we have these tracks. What we have to do is for every single item in this array, we have to render one track, one line in this list. So when we have to do that, in React Native, we have a component called flatList. So a flatList, if I'm gonna render it here, has two required properties. Actually, it's not from here, it should be from React Native. A flat list has two required properties. One property is called data, and this should be an array of things. In our case, our array is the array of tracks. Now, knowing what data it has, we have to specify a function that will tell flatList how should every single item from that list be rendered. So if I take here the item, we need to specify this item will be one track from here, one data point. So we need to tell how should it be rendered. For example, if we simply render a text for every item, and we know that the item is our track, and we can access the name of that track, we can do item.name to render a list of names of the tracks. Look here, we already have a list of titles that are coming from here. As we can see, White Iverson is the first one, and so on. Not sure if we actually need the container. Maybe we will need, we'll see. Okay, so, but the thing is that we need a little bit more information besides this text. So one option would be to actually develop and create how we want to render a track right here, because we can expand it to a view, we can add things, we can style it here. But I don't recommend that, because you will see in how many places we want to reuse the same track list item component, both in the home screen, search, favorites, and so on. So for that reason, I want to create a custom component that, receiving the data about a track, will render a list item that will look something like this. So basically we zoom in on one row. Okay, so to do that, in our folder components, let's go ahead and create a new file called track list item.tsx. A custom component in React is a simple function. So let's define that function, or we can even do it with a function keyword, track list item. It's a function that returns something to render on the screen. For example, it can return a text component that we will import quickly here from React Native. And if we say here track list item, when we will try to render a track list item component, that's what we expect to see on the screen. The return statement is what is being rendered. The only thing left is to export default this function, because we need to import it in other parts of our application. For example, the first place where we will need to import it is in our home screen on the tabs index.ts. Let's go ahead and import track list item. And what we want to do is to render it, for example, let's first render it above a flat list because it's going to be easier. To render a custom component, we follow the same rules as rendering predefined components like a view, a flat list, an image, or so on. So we open the angle brackets, we say track list item. If it needs something inside, we're gonna close. We're gonna have a separate closing tag. However, in situations where we don't need to pass any children, the only thing that will be are some configuration properties. In that case, we can self-close this tag here, similar to how HTML works. So if you do that, the track list item is not visible. You know why? Because my, I'm in dark mode, and if I turn on the light mode, we see track list item here in the middle. But I'm gonna go to track list item and probably add here a style, color white. It depends on what theme you are developing for. So it's also possible to have like to use like this theme text, and that's going to adjust based on the color scheme, but I will not focus on that in this tutorial. Okay, so now that we know how to render a track list item, let's put it inside the flat list to render a track list item for every single track that we want to render. So instead of rendering a text, we're going to render a track list item. And we see the same amount of lines here on the list as we have tracks in our dummy data. Okay, that's good, but we want to render, for example, the information from the track itself. Here is where props comes into place when it comes to React and React Native. Properties are a way to send data from a parent component to a child component. The parent component in this case is our tab 1 screen, which in fact should be home screen. Not a big difference, but just purely for my OCD. And yeah, the parent component is the home screen, and the child component is the track list item. Here we have information about the item that we want to render, which is a song. And to send it down to the track list item, all we have to do is pass it here with a name, for example, track, then equal curly brackets, and here we pass the value of that property, and the value will be our item. That's how we send data. Now let's go to the track list item and see how we can receive data. All the properties of the component will receive will be the first parameter of the function. As I said, components are functional, are simple functions, and this parameter will contain all the props. So if now I will simply do console log props and look into our data here, we see that props is an object with a key track and information about the specific track. Here is important, this key track. Where is it coming from? The key track is the name of a property that we are sending from here. So that's important. The same name that we use here will be the key inside the property. So we can do props.track. And in this situation, we're going to only see information about the track. So what we can do is, instead of track list item, we can render here props.track.name. And now we have back the names of our items, but they are coming from the properties. What I usually like to do is, instead of always writing props.props.props. I like to destructure the data right away here. This is a feature widely used in JavaScript, in modern JavaScript. So if we want to extract the value of a key from an object, we simply say here track, and it's gonna have the same value. So we can ignore that props. Pay attention to the curly brackets. Yes, now it's working back as it was working before. I don't need to console log here. And here a couple of words about TypeScript. As we can see right now, we have an error that the track has the type of any, because we haven't specified what should be the data type of this property. To do that, which is optional, and if you're afraid of TypeScript, feel free to skip specifically this part, which is going to be like 1-2 minutes. But here is a short explanation about how to define TypeScript and how to properly type our properties. So what we have to do is to define a type. Usually I like to call it the same name as my component and advent props equal to an object. An object with a track, because we know that's exactly what we are looking for a track, and it should match it here. And the type should be of type track that I imported from the predefined types I provided you. It should have ID, name, preview URL, and so on. Now the last step is to use this track list item props type to type our properties here. And just like that, now if I hover over the name, I see that the name is a string. And if I do some weird mistakes like, I don't know, avatar, TypeScript will tell me like, hey, there is no property avatar on a track. So probably I made a mistake. So let's go back to the name. That's the value and the benefit of TypeScript. You saw that Twitter is blowing up again, like with some drama around TypeScript, but it's helping us. So get used to it. Okay, so now that we have everything set up, connected together, the next step is going to be to focus on rendering the component of this track list item. So let's look at what it has. It has an image on the left, yes, and in the middle it has the name, and underneath the name of the artist. We already display the name of a song, but let's go ahead and put this text inside the view that will also contain some styles for the container. So don't forget to import the view from React Native, and at the same time let's import the style sheet and start creating our styles equal stylesheet.create. And here is where our styles will go. For example, the first one will be for our container. The container can have, I don't know, I just want to see it on the screen. So I like starting with a background color, I don't know, gray. And if we don't see anything yet, but if we say that this view should have a styles.container, then we're gonna see that the background color of these track list items is gray. So what we can do is, first of all, we will add some maybe margin vertical to add a separation between the items themselves, so 5. Now we see that there is some space between the items. By adding some padding, we're gonna add internal padding in this container, so we can also add a padding 5. And yeah, that's pretty good. Let's go ahead and add the style for our title, and this style is going to contain this color white for the name of a song. And instead of sending here an object, we're gonna do styles.title. And what we can do is provide, besides the track name, below the track name, we also want to render the name of the artist. If we look into the data, we see that the artist is an array and the artist has a name. So to access it, we're gonna do track.artists. Let's go ahead and do at position 0 and get the name. The problem is that in some cases, there might be tracks with no artist. I don't know in what cases that might be, but if this array does not have this property, it will give us an error that we're trying to access the name of undefined. So simply adding here a question mark will safely access the name only if artists has at least one element. And this is going to be a style subtitle. So subtitle, color, I don't know, gray. And I'm gonna remove the background color gray from here. Okay, that's good, that's good. Let me check some styles from there. For the title, I think we also increased a bit the font weight to 500, which should be a string, to make it a little bit more bold, and the font size to 16, a little bit larger. And that's it. Yeah, for now it's okay. So we have the name and the artist name. What about the image? Again, based on the data that we get from the API, the track itself will not have any images, as you can see. However, the album that this track is part of will have an image, and it will have a list of images. So let's go ahead, and for the image, which we will render using a component from React Native called image, we're gonna render it as the first item here, image, and it's a self-closing tag. The image requires the source with an object having the URI property. The URI should be a URL to a publicly accessible image. So let's go ahead and access it as track.album. The album has images. The images is an array, so let's take the first image and also conditionally access the URL of that image. We expect to see something, but we don't. And that's a very common problem when rendering images, because if we don't provide a height and a width, we're not gonna see it. It's gonna be there, but it's not gonna have any height and width. So let's give it a styles.image, and let's implement these image styles at the bottom. It can have a static width of 50 pixels and an aspect ratio of 1 to have a square 50 by 50 image. We can also add some border radius 5 to make it to make the corners rounded, and yeah, it looks good. The only thing is that we wanted the image to be on the left of the text or the text on the left of the image. At this moment, they are displayed on top of each other because that's the default direction how components are rendered. So this container by default will render all the childs as a new row. If we want to change that, we can change using flex direction on the container that contains the elements we want to change the direction of. So if we do a flex direction row, now we see something changed, but at the same time, not exactly how we wanted. Yes, the image is in the same line with the text, but the texts themselves also became in the same line because that's what we said. Flex direction row of a container will put all the childs in the same row, and we have 3 childs: image, text, and text. To avoid that, what we're gonna do is we're gonna wrap our texts inside another view, and this way now our main container has only 2 children: the image and the view, which is a group. And again, the default direction of a view, if we don't provide any styles, is going to be to render them in separate rows. So that's why the texts are back on top of each other. Perfect. I think the image also, the image needs a little bit of margin right. A margin right, how much? Margin right 10, to have some space between the text and the image. And if we want to render that text horizontally aligned with the image, we can do that by doing align items, center on the container, and that will put the image and the texts on the same horizontal line. It will center them. Yeah, let me just check something. Background color red. Think it should be good. Perfect. So, oh no. You see, it's also scrollable in this direction. Because we didn't specify how large the container can be. So let's go ahead and say that the container can only be 100% of a parent. It doesn't want like that. Yeah, this view that contains the title and the subtitle, if we say that the style, using style, that it should have a flex 1. No. I know actually why. Because inside our home screen, we have this view container. So let's try to remove it and leave only the flat list. And yes, it is fixed now. If you want to get rid of the scroll indicator here, you can add a property to the flat list, shows vertical scroll indicator false. And this way you will not see the scroll indicator. Perfect. So that's basically what we have here. Track list item. I think it's ready. And it looks pretty good, displaying the list of tracks. All right, so let's go ahead and do a git add, git commit, home screen, and track list item. Perfect. Let's see if we have any questions. Will you implement play music in background? In background, probably not. We will see. I can point you in the direction of the documentation how we can do that. The text of a name is too large. Yeah. That was a problem, but what we try to do is to say, like, even if it's too large, like, don't go overboard. Basic authentication in Expo router. We actually implemented that in a couple of projects. What will you use to get all the music, and will it be playable? We're going to use Spotify API, and yes, it's going to be playable, but Spotify API only gives us 30 seconds preview of songs. So let's go and continue, because as I said, we still have a lot of things to do. Hello from Dubai. Hello, how are you doing? Are you living in Dubai or just traveling vacation? Okay, so here we have it. Can you show now real quickly what to show? The next step is the saved tracks screen. The thing is that this favorites screen is going to render a list of songs, based on the items that we will save, like we will favorite. So it's a kind of a playlist. The thing is that at this moment, it's very similar to how the home screen looks. It also will render a list of things. So for now, let's simply copy everything from our home screen and put it in the search as well. Let's put it there and only change the name here to search screen. So now the home screen has a list of items and the favorites. No, actually I was talking about favorites. So it shouldn't be search. Let's go back. It doesn't want to go back. But not a problem. We will have that there as well. I want you to do it in favorites. So from index.tsx, which is the home screen, we're gonna copy paste it in the favorites and we're gonna change the name here, favorites. So if we move to favorites, it's still a list of items. So from the UI standpoint, it's the same, but the data is going to be different and we're gonna fetch it by the end of this video. Because we started already working on this search, let's go ahead and open it because yeah, that's the third screen that we will need here. On one side, yes, we will need this flat list, but on top of a flat list, we want to render a search bar. Not sure if I have, no, I don't have a screenshot here, but we're gonna implement it together. So first of all, let's put the flat list inside the view. So the flat list will go inside the view. That should be imported from React Native as well. View. And inside this view, we're gonna have two things. On top, we're gonna have a view with the header view. This is going to be the header. And after that, the flat list with items. Now, inside this header, we're gonna have a text input, a component from React Native that will help us to manage user inputs. And we can start by saying that the placeholder should be what do you want to listen to. Now, if I go to the search screen, the text input is being displayed, but it's just below the top notch here. So the problem at this moment is that our components are rendered behind that notch. That's called the area where it's safe to render things is called a safe area. So that would exclude the top notch from there, which if I do it like this is much more visible. So to do that, we're gonna use a component safe area view from React Native safe area context, and we're gonna replace the root view with a safe area view. And by doing that, we see that our components are being rendered below the notch. So it's safe, we see them. Okay, perfect. In a moment, we're gonna adjust a little bit the styles of this text input, but what I want to do is to render icon before the text input. So the icon will be from font awesome. Let's import it from vector icons. It's going to be called search with this size, and it's there. And I think after the text input, we're gonna have a text saying cancel. Let's import text from React Native. And if I go to the search, yeah, that's probably good, but we have to adjust it a bit. For example, in this view, I'm gonna style it with, we don't even imported the style sheet yet, so let's do that. Style sheet. At the bottom, we're gonna define our styles using stylesheet.create. And we're gonna have the styles for our header, container, and the input. Let's give here styles.header. To the text input, I'm gonna give styles.input. And I don't know, I think for the text as well, style. The text simply has to have a color gray or white. Yeah, that's good. So, as we can see, the icon, text input, and cancel, they are in 3 different lines. What we want is to put them in the same line. So for the header component, let's do here flex direction row. And to align them in the middle, I'm gonna do align items center. Perfect. Now, as we can see, the input does not expand to fill all the space there. So our goal is to render the icon on the left, to render the text on the right, and the remaining space to give it to the text input. That can be accomplished by specifying that this input will have a flex 1. So now it expands all the way and pushes the cancel at the end of there. The input will have a background color. So background color 121314, kind of a gray. Let's add some padding to it. Maybe some margins as well. Margin only horizontal. And let's make the corners, corners rounded. So border radius is going to be 5. Okay, so now we have the input that also should have a color for the text color. Let's do white. So now if I write, it's white. Okay, perfect. But with the styling and positioning, everything is okay. I think we are good there. When I scroll, I see that probably my header container should have a padding of at least 10. Yeah, probably like that, but even more, I think 10. Yeah, that looks better. Okay, so as I said, from rendering and from the styling perspective, the search box works perfectly fine. The problem right now is that when we will need to do the actual search using the API, we're gonna need the value of the string that the user types. At this moment, there is no way to take it from the text input. In order to be able to control the value of a text input, what we have to do is to bind it to a state variable. A state variable helps us keep track of data inside our component. To define a state variable, we use a hook called useState inside the body of our component. useState was imported from React, and it should have a default value. Let's default it with an empty string, because initially there is nothing in the input box. The thing that the useState gives us back is an array of two values. On the first value, we have our actual value of a state, which we can call search. And the second value is a function, a setter, that will update our state variable. Let's call it setSearch. Now, actually, I'm gonna do here default value. Now, if we take this search state value and send it to the text input as the value property, search, we're gonna see that automatically we see default value in the text input. If we're gonna try to change it, it will return back to default value, because at this moment, we only assign the value of our state to the text input, but we never update the state value. We need to bind also to listen to an event when the text changes and update the state. To do that, we're gonna do on change text, and we're gonna pass the setter. On change text expects a function, and it will be called with the value of the new things that are written there. And just like that, we will have access to the search value and do the actual search based on the value that the user types here. Let's go back to empty string for the default value. And what else? I think if we press on the cancel, what we want to do is to remove everything. So that's quite simple. We can add an on press event on the text. And when the user clicks, we will update the search value using the setter, setSearch with empty string. So if I type something and then press cancel, it's gonna clear it out by resetting it to an empty string. Perfect, so now the search screen, the home screen, and the favorite screens are all ready for the next steps. So let's go ahead and do git add, git commit search, and favorites screen. Oh, perfect. So we are doing good progress, because if I'm not mistaken, we are kind of finished. Oh no, we have a music player. I wanted to say that we are finished with the front end, but the next part is actually one of the most exciting. We're going to do the music player that is going to be displayed here on top of our bottom tab navigation. And then we're going to get into the backend. Let's see if you have any questions, guys. Why don't you put it as the flat list header component? There are two ways to render things when we have a flat list. One way is to render it besides the flat list, and in this situation, the component that is besides the flat list will always be visible on the screen, and the flat list will only scroll here. And that's exactly what I want you to do here. Another way, you don't have to repeat after me, I will just show you, is by rendering the component as the list header component. List header component. And if you do that and render it as a list header component, initially it's still going to be there as the header of a flat list, but as you scroll, you're going to lose the header. The header moves together with a list. The things that are besides the flat list will remain on the screen. So it really depends on the user interface. In a lot of cases, we want to have headers. For example, on profile screen where you have a list of posts on the bottom and the profile header at the top, you want it to be the list header component, because when you scroll, you want the header to scroll as well. In this situation, I want to always see the search bar at the top. Faisal is saying, I live, work in Dubai. I'm doing great. Thank you for your great videos. Thank you very much. Ferry is asking if it's a good idea to have a Laravel backend and integrate React Native inside that. If you have it already there, that's perfectly fine. Yeah, go ahead and use whatever you know, whatever you have available. Don't look at all the best practices out there from the tech Twitter. Laravel, I worked with Laravel, I think, a couple of years ago, and to be honest, I really enjoyed it. It makes PHP like great again. I don't know. Okay. A little more front end. In the next step, we're gonna work on the music player. First of all, we're gonna render it, and the challenge will be to render it in this position, always on top of our bottom tab navigator. Then we're gonna implement a global context that will share data about what track is currently playing. And then we're going to use Expo AV to play the tracks, play the sound. So we have 3 steps for this music player, and we can actually get started. So always try to separate things into separate components. For example, this player is going to be a component. So let's go ahead in source components. Let's create a new file, player.tsx. Here, I'm going to define a default component. I'm using here a snippet to generate it, but that's basically an empty React Native component that will simply render the text player. You can copy it from here. I'm thinking whether to show and to do like step by step the user interface of this player, or to take the code, the solution code from here, explain it a bit, and then move to the more interesting part of data sharing and the Expo AV. Help me decide that. Start poll. Should I show you and do it like step by step together, or should we copy paste the UI, only the UI code? Let's see. Help me decide. At 10 votes, I stop, and we do whatever you say, guys. Should we code the user interface of this one, or can we reuse it? Reuse it. No. Yes, reuse it. People are voting. Okay, I see multiple people saying to reuse it. Yeah, let's go ahead and reuse it, because we already learned how to render things like a view, image, text, and so on. And I think it's going to get a little bit repetitive. But nonetheless, I'm going to explain you all the steps, and the more interesting part, which is new, like React context and so on, we're going to do it step by step anyway. So let's copy the code of a player and paste it in our player.tsx. This is the part where I want to explain it to you and to do it together. In the container, there is position absolute. Let's comment that out. and there is top minus 17. Let's comment that out. Now, let's go ahead and import this player TSX and render it somewhere just to see it on the screen. I'm gonna render it in a position where it's going to be easy for you to understand. For example, we can go into the index in the home screen and let's render it as the list header component. Very weirdly, but I just want to render and see it on the screen. Let's render player like this, but we need to import it from components. And it should be visible here at the top, the player. Let me know if it works for you as well. Oh, now the votes are for the do it together. Anyway, it's probably late, but let me explain you everything that this does. And actually, I'm going to, instead of rendering it as the list header component, I'm going to comment out this return flat list from home screen and simply do return player. Just for you to see everything that we have here. So that's our player. If we look at the code for the player, what do we have? First of all, we have a player and the information about the track is imported from the dummy data, and we simply take the first track from that list. If you change here to 1, it's going to be displayed the second track. We take the image from the album, similar way as we did before, and we are rendering the track name and the artist name together with the image. This is very similar to how we implemented the track list item. It's actually the same. The only thing, the difference is the container background, the player background, and having like this icon for heart. And that's it, like nothing more. Everything else is the same. Now, instead of rendering it here in the home screen, you can imagine that this is not the right place where we want to render it. So let's actually delete it because I simply wanted to show you a simple way to render the player. And let's come back to our flat list, basically return back the home screen as it was before. As I said, this player is always going to be rendered on the top of bottom tabs. So to do that, we're going to take advantage of the possibility of overriding the bottom tabs component. So for that, let's open tabs layout. And here we have our tabs screen. The tabs is imported from Expo router, but actually this is the React navigation bottom tabs. So if we look at the documentation of React navigation bottom tabs, you're gonna see that you can override the tab bar. Tab bar, this is a function that returns element to display the actual tab bar. So let's go ahead and see how we can override this tab bar. If I do tab bar here, and if I'm going to render a component like, I don't know, text, tab bar, in that situation, we need to import text from React Native. In that situation, we lose the actual tab bar, but at the bottom somewhere there is this text, which is also displayed with black, so that's why we don't see it. But the thing is that we don't want to get rid of our tab bars. We still want to render them. So what we're going to do is we're going to import the component that is being used there as tab bar. How is it called? How is it called? Bottom tab bar, and it is imported from where? From bottom tab bar. Where did I import it from? I don't think it's from Expo router. Has no exported. No, it should be from React. From React Navigation Native or React Navigation bottom tabs. Yes. So let's import the component bottom tab bar from bottom tab bars and render it here. Instead of a text, we're gonna render the bottom tab bar. The thing is that it also needs some properties to render correctly. Where do we take it from? We simply take it from the properties of the component and we pass all of them down to the bottom tab bars. With this in place, we are back to square one from where we started. We have a bottom tab bars. But we can also add something more here. For example, if I'm gonna add here a view, we can put the bottom tab bars in the view. And we can put something else in the view. For example, the player. Imported from the components, player. Imported from the components, player. And just like that, we have a player here on top of our bottom tab bars. If you want to put it on the bottom, you can put it this way. You see, we are in control of how we want to render the bottom tab bars. So we simply added the player on top of the existing one. We can leave it like this, it's gonna work fine, but at this moment, as you can see, if I'm gonna add here view style, background color red, you're gonna see that bottom tab bar right now it actually includes this bottom tab bar, so it's quite large, and because of that, the items, the page finishes here. So we do not see anything. What I'm trying to say is I really want to see the list being scrolling behind our player and not finishing here. So this is a little improvement, but if you want to do that, because in Spotify that's how it works, what we want to do is to display this player with absolute position in order for it not to take additional space on the screen, for the page itself to go beneath the player. So that's why we have here the position absolute on the container, and if you do that, it will disappear, but the page itself will come all the way down till the bottom tab bars. And with some magic here, top -75, we bring it back here, but now as you can see when you scroll, the items are being scrolled underneath. Where is this top -75 coming from? Well, this view, the player, when we position it absolute, it will be positioned relative to the parent. The parent is this view. And if I will add now some background color, you'll see that the view is basically the bottom tab bar, only this part. So what we want to do is say like move it 75 pixels above the top line. So basically if I decrease it to 65, it's gonna move down. Hopefully that's clear. Minus is moving up compared to the top of our bottom tabs. And it's the same as this height that we have for the container. And with that being said, we have our player there. Position, and it's visible on all the screens. We have this check, like if there is no active track, it's gonna be null. So if I'm gonna do track at position 1, 2, 3, it's not gonna be there because there is no track like that. So this way the player is going to only be shown when there is a track active. So hopefully that makes sense, because I see right now everyone voted for doing the player. So I'll try my best to implement more features and copy less code. But yeah, today there is still a lot of exciting stuff that I want to teach you. So when it comes to the user interface of a player, we are done. So let's do git add, git commit -m music player UI. The next step for the music player is the data that we're gonna take from somewhere. Okay, let's do it again. So the next step for our music player is to have a global context where we will save what is the currently active track, what track is currently playing. We need it in a global context because we want to update this from anywhere in our application. For example, when we press on this item from the home screen or from the search or from our favorites, we want to update that track that is being played in our player. So we need access to that data from different parts of the screen, and we need it access in the player as well. So what we're gonna do is we're gonna define a React context, and we're gonna wrap our whole application with this context, and in that context we're gonna save the currently active track that should play. And yeah, let's see how we can do that. I'm gonna start by defining a folder called providers, and let's start with the, how do they call it, player provider.tsx. We need to start by importing a function called create context from React. Let's start by creating our context called player context. Initially it's going to be an empty object. Now we're going to export a component default player provider, export default function player provider. This player provider will receive a property called children, and this is a specific property. I'm going to show you what exactly is that in a moment. And what it should do is it should wrap around our children the player context.provider, and here we're going to put the children. This way all the components that are coming here as children will be wrapped around the player context, and it will have access to the value that we provide here. And what value do we want to provide is the track that we want to play. So we're going to need a state variable for the track, and set track equal use state of type track, that track that should be imported from our types. So use state should be imported from React, and that track should be imported from types. And it can also be, I think, undefined, or yeah. So the value that we want to export is the track that is currently active, and also a function called set track. We're going to come back to specify a little bit more types here, but for now that's everything that we need. And what we want to do is we want to import this player provider and wrap around all the screens in our application. How do we do that? Well, because we are using Expo router, usually we were wrapping like our data providers and context providers in our app.js. In Expo router we don't have app.js, but we have this root layout, the layout file from the directly from the app directory. This layout is going to be wrapped around all the screens from the root and tabs and so on. So let's go ahead and import here our player provider from providers, and let's wrap it around our stack here as player provider. Now both our tabs and all the descendant screens of the tabs and model and so on will have access to the player provider. If we look at the player provider, we see that we are expecting here a children prop, but we're not sending here any property with name children, because this children is a special prop and it will be everything inside the opening and closing tag of our component. So in this case, the children of the player provider will be this stack screen. And because we are rendering the children inside our player context provider, it means that our stack screens will have access to the data from here, track and set track. To properly type these properties, we can say that it's props with children. And this is a specific type from React that has this children prop. Okay. Now, what we can do is, first of all, when do we want to set the currently active track? We want to do that whenever we press on one of the tracks from these lists. So this component is our component's track list item that renders a track inside the list. So let's go ahead and implement that whenever we press on this item, we want to add it to our currently active track. How do we do that? Well, first of all, we need a component called pressable, because a view cannot handle on-press events. So let's simply change from a view to a pressable for the top component. Make sure the closing tag is also pressable. And now we can say onPress is a function that initially will do console.warn pressed. Now if I press on this, we see at the bottom pressed. So that means that we are handling correctly pressing on the item. Now what should happen is we should call the function setTrack from our player provider. To consume a context, there is a function in React called useContext. By calling useContext with our actual player context, we're going to be able to get access to the track, to these values, track and setTrack. What I'm going to do is I'm going to export a helper function, a helper hook called usePlayerContext that will simply put together the useContext and the player context. It's a very small improvement, but it allows us to use the player context by importing one thing instead of two things, use context and player context. So now we can import this use player context in our track list item. Let's import it from providers/player provider, and we can get access by calling it in the body of our function. We can get access to all the values that we provide here. One of them is track, one of them is setTrack. So what we are interested in is in this setTrack. So I'm going to destructure setTrack from player context, and when we press on this item, instead of console warn, I'm going to do setTrack with the property track. Now, in the player provider, let's do a console log track, just to see if it works. So if I'm gonna, initially it's track undefined, there is no track. If I press on the first one, track should be Post Malone. Here should be a different one. So that means that we are successfully updating the current active track inside our player provider from the track list item whenever we press on it. The next step is to consume the actual track inside our player. So similarly, we're gonna take this time, we're gonna use that use player context, but we're not gonna take the set track. Instead, we're gonna take the actual track. At this moment, we don't need the dummy data with tracks because it's going to work based on the context. Initially, we do not see the player because the track is undefined, but if I press on the first one, it updates. And if we press on different items, it updates. And as you can see, it works from anywhere in the application, from the favorites, search screen, and so on. Because we are using a global context provider that wraps around our whole application, and everywhere from our application, we have access to these values, to the state of currently active track and a possibility to update the track. The last step is actually, we see here that the set track does not exist on type empty. And what else? In the player itself, also track does not exist on this type. Why? Because we didn't type correctly our create context. Let's go ahead and say that define a type here that will specify what values, what data this context will manage. So player context type is equal to an object that will have a track of type track, and we'll have a function set track, which should be a function receiving a new track of type track, and it will return nothing, void. The actual track is also optional, so we can do it with question mark. And yeah. Now, we need to say that this context is of type player context type. And to do that, we're going to use a generic here. We're going to specify player context type. And right away, we see that there is a problem. We cannot create a context with this object because it's not the same as our type. It doesn't have a data that we expect. The data that we expect, track is undefined, so it's okay. But set track, let's implement set track. Let's provide a default value. Like if nothing is provided, that's going to be like a simple empty function. It will not do anything. Now, if we look at the player, the track right now is of type either track or undefined. It's properly typed. And if we look at the track list item, the set track will expect an actual track. And if you, for example, forgot to send something, TypeScript will say like, hey, expected one argument, but 0 given. So that's, again, the benefit of TypeScript. Anyway, now everything should be working and it's also typed. So that's everything when it comes to our global context provider. Again, let me quickly recap everything that we learned, because if you are just getting, like if you have experience with React and React Native, global contexts should be familiar to you and it should make sense. But when you get started, I believe they can become a little bit confusing because we have code like in different parts of application and it's confusing how we get access to it. So a React context is, what is a React context, Vadim? All right, so we create a React context with the data that we want to be available to multiple screens and components in our application. The context itself will contain two things. It will contain the context.provider, which we use to give values, to set values, and the player context.consumer. In our situation, we didn't use the consumer because there are two ways to consume the values. Either with player context.consumer, as you can see here, consumer, or using a hook called use context. It's much, when you work with functional components, it's much easier to use this hook to get access to the data, so that's why we used that one. And we also wrapped it around a custom hook that will be easier for us to import and use in other parts of application. To make this work, we wrapped around all the screens in our application inside our root layout. We wrapped our player provider. So everything that is above this player provider will not have access to the player, but everything that is inside the provider with the screens and so on, they will have access to the player provider. That's why in our track list item, we can use this custom hook that we defined, and we can get access to that function that we can call and update something globally. For example, in this case, we are updating what is the currently active playing track. On the other hand, in our player.tsx, we use the same player context and we got access to the value that we want to use. So this way, we decoupled and separated the logic of data and components, and they can live like in different parts of the application without us having to send this data through a lot of properties. Anyway, that's the data provider, and I hope it makes sense. And we're gonna move on to the next step. Music player data provider. And our next step is to actually make to play the songs that we are trying to play. Why did you use context instead of just end or JOTI? Because it's easy, it's out of the box from React, and for things like this, which doesn't require a lot of data, there is nothing wrong with using the React context. You can, of course, use a global state management library. There are a lot of them out there. But there is, yeah, as I said, there is nothing wrong with using React context for this use case. Which font are you using in Visual Studio Code? I don't know. It's from the theme, from the material theme, I think. Let me grab some water, and then we're gonna continue with our music player. And our next step is going to be to actually play the tracks using Expo AV. So open up Expo AV, and in a moment we're gonna get started with that. And yes, we're doing great progress today. Okay, so let's see. Okay, let's continue. And for the next step, we want to play the audio with Expo AV. So let's open up the documentation. And we're gonna start by installing Expo AV. This library, npx expo install Expo AV. This library is used for both playing videos and audio. In today's tutorial, we're gonna focus mostly on audio. And here is a good example of how you can do that. So yeah, first of all, we're gonna need a state for the sound, and using this audio.sound.create, we're gonna be able to create it and play it and so on. Okay, so yeah, we're gonna cover it step by step. Do we have it here? Yes, we have it. So inside the player, let's define a function called playTrack. playTrack. This is going to be an async function, and when should this function be called? I think we should play the track whenever the track changes. So for that, we're gonna use a use effect and say a use effect with a dependency list with the track itself, and we can check if track is defined, then we want to play track. Okay, so let's do here console log playing. We can do track.id just to see if it works. It still says that the track is possibly undefined, so let's add here a check at the top. If track is undefined, we want to stop here. We don't want to do anything. And in this case, I don't think we need to check it here as well. So it's going to be simpler. Now, if I press on a track, we should see a console log saying playing this track. And if I change, it should update saying playing. So as I see, whenever we move the song, it's calling this function that we define, play track. Now, based on the documentation, we see that in order to play an audio, we need to first create this sound. So let's go ahead and import audio from Expo AV. And here we're gonna say const sound equal. It's gonna be an async function, so await audio.sound.create async, and here we either provide a source of a file from local source, or we provide an object with the URI. The URI should be a URL to an accessible sound. So if we look in our data, some of our tracks will have this preview URL. The first one, I put here a publicly available URL of a sound with the idea that this URL is not going to expire later and you're going to be able to test it. You can test it by actually opening it in your browser and seeing if it's still available. Because if it's not available in the browser, I don't want you to spend a lot of time figuring out why you don't hear the sound. Anyway, let's go ahead in player and say that the URI of a song is going to be track.preview URL. We see the TypeScript is complaining because the URI should be a string, but our preview URL can also be null. So what I'm gonna do is I'm gonna check here if track is undefined, or actually let's do it with if track.preview URL is undefined, then return. And this will catch all the cases, like it either track is null or if preview URL is null, it's gonna stop here. Otherwise, the sound was going to be there, and I don't think we can hear something. No, because we need to play the sound. To play the sound, let's call it actually here new sound. To play the sound, we're gonna call new sound dot play async. Because it's async, we should also do an await here. And just like that, I already start hearing the sound. There are some reasons why the sound might not be you might not hear the sound, and that has to do with the sound of your emulator. Make sure you turn on the volume, and also make sure that the phone is not in silent mode, because in silent mode the sound will not play. And after you turn that on, if it's still not playing, just refresh the page to start playing the sound again. Select the first one, wait for a couple of seconds for it to load, and hear some piano music. Not all the songs have a preview URL. So in order to show that, as you can see, we are rendering the play button with a gray if it doesn't have a preview URL. So if you select a song and the play button is gray, that means there is no preview URL. So just look for one. Look for one that has it. Oh, yeah. And be careful with that at this moment, because we are only loading sounds, we are never unloading them, so stick to it. We're gonna fix it. It's gonna be a mess if you try to play a lot of songs. All of them will play at the same time. In order to avoid that, what we have to do is to save this sound in state and make sure to unload it when we're trying to play the next song. So let's go ahead and define a state with sound, set sound equal use state, and initially it's going to be undefined, but the type of it is going to be sound. This can be imported from Expo AV build audio. And let's go ahead and before we play the new sound, we're going to do set sound, new sound. The trick that we're going to do is at the beginning of this function play track, we're going to check if we have already a sound in our state. That means that the previous music is still playing. So what we can do is check if sound, then I want to first do sound.unload async. Basically, when trying to play a track, first of all, stop the previous one, unload it from memory, and only then create the new one and play it. And this way, if you're gonna try to play different songs, it's gonna not play all of them at the same time. And if you choose the one without play URL, it's simply gonna be silent. Perfect. So that's how we can play these sounds. What else? I don't need this playing. Play track, okay. So looking through the documentation, yeah, we see how we can create, we see how we can play. I think we can also define this use effect that will automatically always unload sound after using it to prevent memory leaks. Let's go ahead and... Why are you doing that to me? Let's use this use effect in order to unload the sound when we unmount the component. So yeah, this will avoid some memory leaks whenever we, for example, close the application or we unmount the player completely. Okay, what else? We're not really interested in recording sound. Here is some documentation about playing and recording audio in background. On iOS, you need to specify some background modes inside your info, inside your I want to also show you something important, specifically around the on recording, on progress update. No, yeah, the progress update. First, no, yeah, before that, what I want to show is how we can pause playing the song. So if you play it, when I press on this icon, I want to pause it. Let's first of all add here on the play, let's add a on press event and call a function on play pause. Let's implement that function at the top here. Const on play pause. And we're gonna work with that sound from our state to play or pause it. So we can do, if sound is not defined, we don't have a sound to pause or play, so we're gonna return. Otherwise, we can do sound dot pause async. And here we can do a wait. This should become async. And missing a semicolon, come on. Oh, it added 2 times async. Now, if I'm gonna play this one and press on this icon once, it's gonna stop it. But if I'm gonna press it again, it's still gonna call this pause async, which is not exactly what we want. We want a possibility to track if it's currently playing or not. I don't think that the sound itself has its sound. Is no. It doesn't have a possibility to check if it's playing or not, and we will have to track it on our own. What we can do, however, is to register to some updates of what's happening with the sound itself. For example, at what position it's playing, if it's playing, the volume, and so on. To do that, if I'm not mistaken, we're gonna have to look into the Expo AV. Where is it? AV. And there should be this on playback status update. On playback status update, and where do we put it? Playback object set on update. Yeah, okay, I think I understand. So we need to define a function called on playback status update. This function will receive status and it will, let's do console log status. Now we need to attach this playback status update to the new sound that we created here. And I think we do that by calling new sound dot set on playback status update, and we set this function. And now the sound will call our function with a new status. I want to also type the status because it's very important for us to understand AV playback status. AV, because it has a lot of data, so it's going to be easier for us to navigate it. Playback status. Now we have status here. Let's see what's happening. So if I'm playing this one, you see a lot of our function being called a lot of times. And it has a lot of information like what's the duration of the whole thing, if it's muted or not, if is the position where it's playing, with that we can show like the progress, if it's playing or not. So is playing is false. This is the last one, but before is playing was true. So that's exactly the thing that we're looking for. We need to know if it's playing or not and save this information in state. Const is playing, set is playing, use state. Initially is going to be false. Initially is going to be false. And in the on playback status update, we can check if status dot I think is loaded. If it's not loaded, we can do return. Otherwise, the status will have data. Now we can check if status dot is playing. Well, we can do here actually set is playing, status is playing. Now, this function will update our state variable, and then we can go and in the icon itself, based on the state variable is playing, we can display a different icon. For example, if it's playing, we will display the pause icon, otherwise the play icon. And as you can see, it works. And the same thing here in the on play pause, we can check if is playing when we want to pause a thing. Otherwise, we want to call sound.playAsync. Okay. It's pausing. I'm not sure if you can hear it, but yeah. And if I play, it calls this playAsync, which behind the scenes will call this status update. Will update that it's playing, will update the state variable, and the state variable will update what we render in the icon. So it's a lot of back and forth, but this way we'll let the player itself manage whether it's playing or not, and we are just listening for updates. This playback status update is very useful function, and you will use it for a lot of things if you want to adjust how you want to render and interact with your player. Check all the data in the status that you receive. You can look more in the documentation. But for example, some of the things that you saw here is the position milliseconds. Based on this, you can display the progress bar because you know how many milliseconds has already been played and the duration in milliseconds, and you can divide that. You can have a lot of information here that you can play with. Anyway. With that, our player is actually ready. But when it's paused and we change it, it's playing, yeah. And then we can pause it. Awesome. So that's the basic and the most important things that you need to know in order to work with audio and how to interact with it, how to manage it, how to play it, load, unload, pause, play, listen to updates. And that's the most of the things that you're gonna need. Let's go ahead and do git add, git commit, music, play audio with Expo AV. If you have any questions, please let me know. Otherwise, we are moving to the backend. So, components, player, that's our player. Can I use Expo AV to embed videos? For example, YouTube videos. You can use Expo AV to play videos using a video URL. So basically, the URL of YouTube is not a URL to a video. That's the problem. So I'm not sure if you're going to be able to embed YouTube videos. Because let's say dummy video URL, a proper URL for video will end with, for example, MP4. So something like this that ends with MP4. And when you open, you actually see it just the video, like without any user interface. This is a URL to an MP4. So this one we will be able to play with Expo AV. That's the same with sound, like. Okay. So we approached the middle of our project. As I said, this is going to be a full stack project. So far, we have worked on the client side at the mobile application using Expo and React Native. We have some screens ready, we have our music player ready, and the next step is going to be to bring some data from a real API. Now we're moving on to the backend side of our tutorial, and for that, what we're going to do is, first of all, we're going to use the Spotify API. Spotify offers an API, and it's quite simple to get access to it. You can sign in to developer.spotify.com using your actual Spotify account. After that, we're going to look at the documentation and explore how we can, what do we have available to work with, but that's in a moment. Then what we're going to do is, because Spotify API is a REST API, we will use StepZen to transform it into a GraphQL API. And not only to transform, but to build our GraphQL API layer that later on will allow us to integrate with our custom backends or custom databases. In this tutorial, by the end, I'm going to show you how we can also integrate with a Postgres SQL database for managing custom features. I believe that if you're using, for example, a public API like Spotify API, that's not the only data that you will need, because otherwise, what application you're building? You're building Spotify. So most probably you're going to want to add some custom features. You're going to want to integrate this in your own data. So when you have use cases like this, that you depend on data that lives in different parts, different servers, different APIs, different structures, and so on, StepZen comes into play to help you put everything together into a combined GraphQL API. And that's very powerful and quite easy to do. And later on from our React Native application, it's going to be way easier to query and fetch the GraphQL API. So yeah, on the React Native side, we're going to use Apollo client, and we're going to build like all of these queries. It might sound complicated, but as always, I'm going to provide like everything step by step. So I'm pretty sure you're going to manage to follow along and implement everything together with me. Okay, so going back here, yeah, let's start with the Spotify API. Let's go here for the documentation. And what you want to do is you want to log in to your account using your Spotify account. So in the dashboard, what you're going to see is I already have an application. In your case, probably you don't have. So let's go ahead and do create application. not just music for the name. You can provide some description, website, educational purpose only. For the website, I'm going to provide our website and the redirect URL also. It's not that important for us, but it is required here. So let's do I understand, save, and this is our newly created API. Back to the documentation. Where is the documentation? Documentation, web API. Here is our documentation. Back to the documentation. We will see here all the endpoints available to us that will allow us to get information from Spotify. For example, if we want to get a list of recommended tracks, we can look at the tracks here at the bottom and see the get recommendations. Here you can read more about what information it receives and how we can what data we can send to the API to get the right recommendations, but on the right you can adjust it a bit. For example, I'm not going to have any artists, but in the genre I'm going to say, I don't know, pop. So if you do that, scroll down until the end and say try it, you should see the response sample here with some tracks, ID, images, name, no-brainer, and so on. So that's already like a lot of data that we have access to. All right, now it's important to explain how the authentication works. So all of these APIs calls to get data from Spotify, they require where is it? They require an authorization token. Without the authorization token, if we simply do the request, it's not going to work. It's going to say unauthorized. In the documentation here, the authorization token is generated automatically for us. But in our case, what we have to do is we will have to generate our tokens for ourselves. And the tokens that are generated are short-lived tokens, meaning that they are only available for 1 hour. If we look at the concepts, access tokens, you can have a look here and read more about that. The access token is required for all the requests, and to generate it, we are going to use the, where is it? The tracks, users. There should be a token. API authorization, I think that's where is the documentation? I think I have a URL in our guide. So request an access token. The following API requests should use an access token. We can generate, okay. It's API/token, but where is that data? Where is the documentation, I mean? Request an access token. So where users. Yeah, as we can see, to request an access token, we have to execute this command. We have to send a post request to the spotify.com/API/token. And we need to provide our client ID and client secret to that request in order to generate the short-lived token. So let's try to copy this one from here or from our documentation. I'm gonna open the notes in order for us to Why I cannot zoom in here in the notes? So let's again copy this from here, or better copy it from our documentation. Let's put it somewhere in some notes. And what we have to change is we need to add this client ID that we can access from our Spotify developers dashboard settings. And this is the client ID. So let's copy it and replace it where you see your client ID. Let's put that here. And for the client secret that we can take it from here, we will put it inside your client secret. Make sure not to remove more than it's required, and we have only to do 2 changes here. Now let's copy the whole command from here and let's open a terminal. I'm gonna open it full screen. I'm gonna do clear and I'm gonna paste this curl command. Let's press enter, and back we receive an JSON object that contains an access token. This access token, as you can see, expires in 3600 seconds, which stands for 1 hour, and we can use it for the next requests. Let's go ahead and save it also somewhere in our notes, access token, because we are gonna probably need it for a bit. Let's review a bit how we can request, for example, artists' data. Let's copy this curl command. Let's paste it somewhere in our notes and copy the access token that you generated for yourself. Here it should be yours, and replace it with your access token for the authorization. Leave a bearer here, or bearer, I don't know how to pronounce it, but replace only the your access token with the actual access token. Now copy this curl command, open the terminal, and we can paste this command here, and that's the result we see. This is the information about the artist with the ID that we specified, and we see the image, we see the name, Radiohead, popularity, and so on. So that's the approach we take to test out the API endpoint, to see what data we receive, to make sure that the requests that we are composing are correct. And it's important to understand that this access token that we are generating here, this will give you access only to general data and not to user data. If you need access to the user data, such as users' history, users' playlists, users' recommendations, and so on, for that you need extra authorization using auth 2.0 to let users give you access to their data. So we're not going to cover that. We're only going to cover like this publicly accessible data, such as tracks, music, and so on. So for that, the way we generated access token is enough. So next step. The next step is going to be to transform from these URLs that we see here, for example, this one that gets information about an artist, to use this endpoint from Spotify, import it in our StepZen API, and have our GraphQL endpoint. So now we're getting started with StepZen, and yeah, it's quite simple to use it to create our GraphQL API. All we have to do is to install StepZen globally on our machine. So let's go ahead. We're gonna come back to the Spotify API in a moment once we actually map it to our GraphQL API. I just wanted to give you an introduction to see where you can find more information and how everything is linked together. Now let's go ahead and install globally StepZen. While that is happening, you can sign up for a free account on StepZen. I'm gonna go ahead and open the dashboard. After you sign up, you will need your credentials. Your credentials are here under the keys. So open it up and come back to your terminal because we need to authenticate from our StepZen CLI. To do that, we're going to do StepZen login. And here StepZen will ask us about the account name. Take it from here. Account name like this. What is your admin key? The admin key is going to be this one. Copy. And I think that's the only thing that it will ask you. After that, press enter. And if you go ahead and write StepZen, who am I? It should tell you the name of account and everything else. If that is done, we are ready to start creating our StepZen project. To do that, I'm going to create a new folder called StepZen here in our React Native project. Let's go ahead and open back our terminal and let's cd inside StepZen. Now, there is no extra commands to initialize or set it up. The only thing that we will do next is use a magic command called import to parse a REST API and create our GraphQL API. Let's look in our documentation what we have to do. So the first step that we're gonna do is about recommendations. I want to fetch this recommendations API, and you can look at the Spotify docs about this endpoint here. And what we will use is we will use this property for the genres, and we're gonna parse it, send it there. So with a simple curl command like this, we can get a list of recommendations. You can copy it, replace your access token, execute it, and see the result. I'm not going to do that right now. We can move on to the next step and start importing it into StepZen. The import command will execute the same query as above. We're going to have to add the header with our access token in order to let StepZen actually parse it properly. And we're going to provide some additional specifications like the query name, type, and prefix, but I'm going to explain what are they in a moment. For now, let's copy this command from here, move it in our notes, and what we have to do is this, instead of your access token, to actually put a valid access token that you generated in the last hour. Because if it's expired, it's gonna fail. So I pasted it here, and then I will copy back all the StepZen import command. Let's open up back the terminal. Make sure that you are inside the StepZen folder that we generated, and let's execute this command. What would you like your endpoint to be called? I'm gonna press enter to go ahead with the default one. And we see that it successfully imported the curl data source into our GraphQL schema. So in a couple of seconds and a simple magical command from StepZen, what happened behind the scenes is StepZen fetched the data from there, analyzed it, introspected it, and parsed it, and created a GraphQL schema based on that. If you open StepZen, we're going to see a folder called recommendations. Recommendation folder name is coming from this parameter name. That's why we specified it here. Name recommendations. Okay, that's the folder for our recommendations. In the index.graphql, here is all the types, all the GraphQL types that were automatically parsed for us. And if we scroll down until the type query, here is the query that will, when executed, will go ahead and fetch the recommendations from there with these headers, with these variables, and so on. As you can see, it also has like all the types for the response, for the track, and so on. So from the data that you saw there, which is very unstructured and quite a lot, if you open it here, now everything is separated in separate types that will be able very easily to be fetched using GraphQL. The next step is to go ahead and deploy our API and try to play with it, try to query some data. That's the power of GraphQL. So with StepZen, that's super simple. All we have to do is do StepZen start, and that will deploy the API to StepZen. You can also deploy it to your own servers and also on AWS as well. But I think that the easiest way is to of course use StepZen API, infrastructure, because it's as easy as running StepZen start. What we see here is a URL here, explore it with graphical. So I think that's the one that I want to open. And what I did, it open this dashboard here with already a query initialized. If I run it, we see some problems because in the variables, I'm not sure actually what exactly will be the initial query that you'll see here. So I'm going to delete everything from here and start from scratch. What we want to do is let's go ahead and open the builder from here, and it will open on the right the visual builder of our queries. So we see that at the moment we have this recommendations query. We can open it up. We can specify a variable for the genres, for example, pop. And we can open the tracks sub-object and select the fields that we are interested in. For example, if you're interested only in the ID and the name of a track, we can do that. We can execute, and we're going to see a list of tracks with their ID and name. And that's what I love about GraphQL, because you can specify what data you need. Instead of having to work with these kind of objects with thousands of data points in screens where you only need, for example, title and the avatar, is kind of, it leads to overfetching. So with GraphQL, we can specify that, hey, I really want only the ID, name, maybe the artist ID and name, and this way we also have nested objects that we can get from one single request. I'm gonna probably zoom in a bit for you to see better, but yeah, that's how easy it was to create this GraphQL endpoint that now gives us recommendations. What do you think about that, guys? I started explaining you for example, the name here. The name property maps to the folder name where we will keep the schema for this URL. Recommendations. Now, if we open index.graphql, we have the type query with recommendations. These recommendations is the query name. So the query name recommendations, where you can do here get recommendations or fetch recommendations, anything that makes sense. The query type recommendations with a capital R is the name of the response here, because otherwise it will be named root and it might collide with other types when we continue working on it. Because the name of the other things like recommended, like other types, is properly parsed from the response. The only thing that is hard to parse is the root one, the what's returned. What else we have here? Query name, query type, name, and prefix. Prefix, we prefixed all the other types with recommend. Again, with a goal to not have multiple types in our schema. For example, album from recommendation, and album maybe from tracks, and album from other parts. So that's why we prefixed all the types with recommend. Okay, so that was our first endpoint, the endpoint for the recommendations. We deployed it, we saw how we can play, and using this dashboard is going to help us a lot, because every time before we integrate some queries in our application, we will come to this endpoint and design the query that we need. Based on the data that we need on that screen, we will test it, make sure that everything works, and then we're going to copy it in our application and implement it there. Now the next step is going to be the query to generate a token. Right now, basically, remember the query that we sent to the first one, this post request to the API/token. This was a query to generate a token. So if I'm gonna do it again, you're gonna see that it's a query, and back it returns a JSON object with access token. Let's import it to our StepZen, and we're gonna do that with this StepZen import command. Copy this command from here in your notes. And what do we have here? We have curl post to the token. Might have some errors, but we're gonna see. And we need to replace our client ID and client secret. This is the only request that doesn't use an access token. It rather uses the ID and secret of your API that you can take from your Spotify dashboard. So let's take the client ID and replace it here in the data instead of your client ID. And the same using the client secret. Client secret, let's replace it with, client secret. The query name will be get token, the query type token response, and the name authentication. Auth for the folder name. So let's copy this one from here. Make sure to go back to the StepZen directory to generate it there. Copy the StepZen import command from your nodes with your client ID and secret, and let's paste it in our terminal and press enter. StepZen will go ahead, execute this post request, and this is a bit different because it's not a GET request, it's a POST request, and StepZen will automatically map a POST request to a mutation. So we're gonna, no, it's actually a query because we are getting the data. So if we look authentication index, we see that it's pretty simple. It has get token, it has client ID, variables, client secret, and it will call this API with the following headers. The only thing that is a bit weird here, not weird, but the only thing that we will have to change here is this client ID and secret. Because right now I have actually if you didn't close the terminal where you ran StepZen start, StepZen will automatically watch for updates and refresh. So we saw that in 2.7 seconds it updated and refreshed the API. So we can go back to our dashboard, refresh the page, and in the queries, we should see a new query called getToken. GetToken has some variables here that it expects us to send from the client side to the query in order to generate this token. The problem is that that's the whole point. We don't want client secrets we don't want the API secrets on our client side. And we don't want to put the user to have his client secret and client ID and so on. So instead of having them as variables here, I want to, first of all, this grant type. What's this grant type? If we look at the request for the API token, this grant type is actually something static. This is grant type equal client credential. It's not a variable. It will never change. So let's copy it from here. Let's go back to index GraphQL to the get token and add it to the actual endpoint like this, grant type client credentials. Now we can remove it from the variables because we hard-coded it inside the endpoint URL, and when StepZen will execute this URL, it will have this variable. Now what about the client ID and client secret? We could also add them hard-coded here, but that's also not the best approach because we want to separate configuration files from schema definition files. So what we can do with StepZen is have a configuration file. Let me quickly find it. Configuration, yes. We can have this configuration. Let's call it auth config. And the client ID and client secret will be provided by the configuration. So we don't need them here anymore. We can remove it together with the parentheses. And we need to only add them to our endpoint. Otherwise, we will not be attached. So after the client credential, let's put an AND operator. Should be client underscore ID equal $ client underscore ID, and then AND for the second parameter client underscore secret equal $ client underscore secret. I made a typo, so make sure double check not to have typos, or copy paste it from our documentation here. In the endpoints, it has this client ID and client secret. Now we need to create this authentication configuration and provide the client ID and client secret. We do that inside our StepZen folder. We need to create a file here, config.yaml, and it will have a configuration set. Configuration, the name of a configuration. Where is it? The name of a configuration is going to be the name that we specified here, configuration of config. It should match. And then we have variables. For example, the ones that we specified with $sign here, for example, client ID in the config, should have your client ID, and client secret should have your client secret. I'm gonna go ahead and paste mine from the dashboard. Where is it? Here, client ID, your client ID, and client secret, client secret. Now, if we didn't make any typos, we can also look at the StepZen start to make sure that it didn't show us any errors. I mean, the last one, the deploying last one, worked correctly. We can go back to our StepZen dashboard, refresh, and we will see that the getToken query already doesn't require any variables. Everything is set up and configured on the backend, and when we execute this one, it simply returns us the access token that we need, and we can use it for the next queries. So as you can see, like, this is really valuable because we have set it up once on the backend, and we keep our secrets and API keys securely. We can also provide them as environment variables to the StepZen in order to keep them as secure as possible. Now with this access token, we can look at the recommendation API and think about how we can kind of put them together. Because at the moment, if we look at the StepZen recommendation index here, we see that the actual StepZen configuration is using a hard-coded token that we provided when we executed curl. When we executed StepZen import using curl. At that point, we needed that that authorization to be able to give StepZen access to the Spotify API. But after 1 hour, this one will be will expire, and trying to execute the recommendation API here, if I'm gonna remove everything and then do recommendation tracks, I don't know, ID and name for the rock. If you're gonna do this query later after 1 hour, you're not gonna see red tracks, you're gonna get an authorization error. So what we have to do here is, instead of this hard-coded value, I will leave a bearer, but I will add it as a variable called access token. Access token. Now this access token should come from somewhere. Let's start by using it, taking it from the variables of the query. So access token should match the name, should be a required string, because without access token we're not going to be able to get anything. Let's save, let's double check that we don't have errors, and let's go back to our API. Now if I refresh, remove this get token and check the recommendation, it asks us for a recommendation token. And if I provide something invalid, you're gonna see the unauthorized. So now the first step is going to be to execute the get token. After getting the token, we will copy the token and we can execute another, for example, recommendation by pasting the token here and saying that we need rock music and taking the tracks like ID and name. And now it's back to working, and it will always work because the access token is, we are able to send the access token through variables, and we can make sure that it's always up to date. It's always a fresh access token. But you can imagine that from our application to always have to execute first the get token request, get the result, save access token somewhere. Then every time we execute another query to make sure to read it from storage, then send it as a variable to the query. You can understand that this is not very user-friendly. Can we do something about it? Yes, we can do something about it. And using StepZen, we can create a query that will execute multiple queries in sequence. In our case, the two queries that we want to execute in sequence is first, get the token, then using that token, get recommendations. Or first get token, then using the token, get track details or search, and so on. So how can we do that with StepZen? Let's go ahead. Back in our recommendations GraphQL, we're using TypeScript. Yes, we're using TypeScript. So back in our file here, what I will do is the query that has access token, I'm gonna prefix it with underscore, meaning that I don't want this to be like a public query. This is only for making it work internally. The query that is going to be public, we can define it manually, but this one, because it's public, we will not need the access token. We will only ask for the genres. It will return the same response as this one, recommendation. But instead of using a REST directive, it will use a sequence directive, sequence. And a sequence directive can specify multiple steps, which are the different queries that we want to execute. So the first query that we want to execute is going to be called get token. This name, where is it coming from? It's coming from the authentication index, and here we have a query name get token. The get token will give us a token response with the access token. So back in our recommendation, we can define the second step of our multi-step query that will execute the underscore recommendation, but it will also have some arguments. I want it from multiple lines. Come on, steps. The arguments, it will have one argument, which we can define as an object. The name of the argument, where is it? Name of the argument is going to be access token. No, it's seed genres. And the seed genres will come from argument. So the name shouldn't have quotes. And the argument is this seed genre. So basically we are connecting, like, pass the value that you received here down to the underscore recommendations. And I think just like that, the get token will pass the access token here. And if we look in here, we have a problem. Argument should be argument, not with S. And I think it doesn't have to. Okay, that's better. Bad request, argument steps has invalid value query get token. Sequence steps. What am I doing wrong? Sequence steps query recommendations. I believe it's true. Everything looks correct. Maybe I have some typos. Argument steps has invalid value. Steps in field argument. In field argument. Oh no, here it's argument, but here is argument. That's correct. By the way, all of this code you'll find in the documentation here for the recommendation. I just wanted to do it together with you. Now, if we, instead of executing this query that requires an access token, if we're gonna use the recommendation that we defined with a sequence, let's refresh our dashboard and see that in action. So these recommendations requires the access token. This one without underscore in front requires only the genre, for example, pop, and the tracks will have ID and title, name. Let's execute. And if everything is correct, we should see it, because what happened behind the scenes is we executed this recommendation. Because it's a sequence, it first executed the get token, and only after receiving token, it executed the underscore recommendation and used the variable from the get token, which is the access token. So that's how we implemented a better way of authenticating. And now from our front end, instead of having to send a couple of queries, like first authenticate and after that get like recommendations, we're gonna right away send a query to recommendations. We're gonna provide only the variables that we are interested in, and we're gonna receive the data in our application just like that. So yeah, that was our authentication and how we can connect multiple steps, multiple queries with a sequence directive. Let me go ahead and do git add, git commit -m. Initialize StepZen and implement authorization and fetch recommendations queries. Okay, so that's good. We can fetch recommendations. We still have to import a couple of them. For example, a query for searching for tracks. Searching for tracks, here is the documentation from Spotify. You can specify the type. For example, instead of album, we're gonna search for tracks, and in the query is what you want to search for. For example, an F. And if you try it, you're gonna get a response with a list of tracks based on that search query. So here is the curl command to test the API. And here is the StepZen import command to import the search endpoint to our GraphQL API. Let's copy that in our nodes first, because we need to append that access token. We still need to append that access token here, because that's the first request that the StepZen will send. It's not the request that it will send later when you do queries. So the way I did it was new text file here. I imported it here, and for the access token, if you lost your access token the same way as I did right now, I will go to the dashboard. I'm gonna remove a query, and I'm gonna execute this get token request to easier generate a token. And as you see how much easier it is than interacting with a REST API with curl and so on. I'm gonna paste it here. It's import command for the /search. It will have a query name search, the folder also search, and so on. So let's copy it from here. Make sure that we are in StepZen, and let's paste the import command. Successfully imported. Let's go ahead and open our search folder with index.graphql. And if we scroll down until the query, we see the search query. The search query has this Q, which is for the query, like the data, like the string that we want to search based on, and it has a type. We can leave a type maybe as a variable. In the documentation that I provided, I hard-coded the type here as type equal track, but you can leave it there. You know what? That will allow you to search not only for tracks, but to have an option from your front end to search based on different fields. So I'm gonna leave it here, but what I'm gonna change is I'm gonna remove the access token from here, and I'm gonna add it as a parameter. Access token is a string and it's required, and we're gonna implement the same logic for the search. We're gonna make this one with underscore that logically specify that this is a private query, and for the public one search, we're gonna have the same parameters, the same response. Well, not the same parameters, because we will not gonna have an access token. And using a sequence, maybe we can take it back from the recommendation. The sequence, not to type it again. Let's put it here. The first one is going to be get query. The second one is not underscore recommendation, but underscore search. And for the arguments, we're gonna have, first of all, Q. And for the second argument, name is going to be type, and argument is going to be also type. Now let's check in the StepZen start if it was deployed. Yes, it seems that it worked. And let's go ahead in the dashboard, refresh our page, and see if we have a search query. We have underscore search, but we're interested in the search. And it has query. The query can be, I don't know, pop. And for the type actually should not be a string. The type should be an enum. And you can leave it as string, but if you send something like ABC, it's not gonna be exactly what you're looking for. ID, for example. It's gonna say bad request. Because the type, if we look in the documentation, the type array of strings, allowed value, album, artist, playlist, and so on. So we can take this list of values and say that a type, we can define an enum here. Enum, search types. Let me remind GraphQL enum how to define them. Location type, and yeah, we just simply specify the names, but it should be without let's see if it will work like this. Should be lowercase, yes, lowercase enum, search types, and all the values that are available, and we can use the search type instead of a string here for the property here, and also to the search in both places, search type and search type. Let's look if it was deployed. It's still deploying. No, I think it was deployed. And we can go to the dashboard, and now if I'm gonna refresh, and try to, I'm gonna delete this one and look at the search, we're gonna see that the type right now is a selector. So we can search for a track with a query NF, and make sure to also select some items from there, ID and maybe name. Bad request. Bad request. Is it actually because of this argument type has invalid? GraphQL. List, not list of strings, but one of strings. I think the enum is not being parsed correctly. How to have enums to resolve to strings? Yeah, that's what I need. Enums that resolve to string. So I think I'm gonna come back to string, string, and I'm gonna simply specify track here because the enum is not parsed to string. So I think there should be a way, but I don't want to spend a lot of time right now. So for the type, I'm gonna do track. For the query, NF, tracks, items, ID and name. Let's see if it works. It's still bad request. It's still bad request. Why? Query. Bad request. What if we try the underscore search? But for that, we need a token. So first get the token. And after that, try the underscore search with token. With Q and F, type, track. And let's try some items. As well, bad request. What am I doing wrong? Maybe I have a typo. Oh yeah, I didn't put in the search, I didn't put the access token in the value, in the header. So I need to put access token here. And maybe the enum will work, you know? Let's try. Refresh. Recommendations, not recommendations, search, type, track, query, NF, and for the items, ID, send. Yes, it works. Name and maybe the artist name. And as you can see, it actually searches properly. And if we look for maybe album, the list of tracks is going to be null because, yeah, actually at the end of the day, we only parsed the tracks. We didn't parse anything else. So it will require some adjustments to the result of how we're parsing it. But yeah. So for that reason, I'm gonna actually add the type here, track, and remove it from the variables, just to keep it a bit simpler. Type track. So now when we search, we only need to specify the query. This type should also be removed. Query nf tracks items ID name. Yes, it works. All right, so that was our search queries. We imported it, we configured it with our authentication. So we can do git add, git commit -m search query. We still have to import, I think, 2 more queries, the track details. Actually, only one more, the track details. And then we're gonna move on to our client side to see how we can query this data in our application. So stick with me for a little bit more, and then we're gonna get into the querying it. Now for the track details, you can open up the documentation to see how it works. You can execute a sample curl request to see it in your terminal, or we can get right away into the StepZen import part. Let's copy this command in our notes. Let's paste it here, and we need our access token. I will copy it from the query above, and I will put it here. The only thing that is different now is these path parameters, because as you can see, the ID of the track is part of a path. It's not part of the parameters after the question mark. So by specifying what is the structure of our path, StepZen will automatically map this number to a track ID and replace it with a variable. So if we copy this one and make sure that we are in StepZen still and execute this command, the path parameter name is not allowed. What happened there? I have probably a typo. Track ID, path params. Path parameter name should be valid. GraphQL identifier prefix with $sign. Must be escaped. It must be escaped with $sign. So does it mean that I have to do $sign here? Path parameters do not align with the URL path. There is some issues with this one, but I don't know what. And it says that it doesn't align. And I expect it to be only with one of them. But it's not a big problem. I'm gonna try it again, but yeah, it says $sign. Maybe I should somehow escape it, but how to escape it? With this sign? With backslash before $sign? I could try that. And it's working. So I'm gonna also update it in the documentation for you when you're gonna copy it to not have any errors. Track details, and it should have this one here. Successfully imported. So if we look right now, we have a new folder, track, with a query to get the track. Now, yeah, as you can see, it has this variable track ID here that is coming from our parameters. Now the last step is to go ahead and add our authentication layer, similarly how we did it before, by adding here access token as a required string, and the variable access token here in the headers, access token. Now let's do get track with underscore and specify a new get track function that will have almost the same definition. The only thing, it's not going to have access token because it will be responsible to get it itself. Now we can copy it from the search, the sequence syntax. And the first one will be get token. The second one will be underscore get track with arguments track ID. And here track ID. And with that being said, we can look, we have a problem. Can only be defined once. Yeah, because it should be, the second one should not have an underscore. And if we don't have any errors, we can go ahead and open our dashboard, StepZen. Where is it? Here. And for example, from search, let's copy one of these IDs. For example, the ID of the song Let You Down. So if I copy the ID here, and if I'm going to remove a query to try the, I'm going to have to refresh. To try the query get track, we're going to paste the ID that we just copied in track ID, and we can get information about the track itself, like name, the artist name, and maybe the album name. If I do that, we see Let You Down by NF and in the album Perception. The best rapper ever. Anyway, I think with that we have all the queries that we will need in our application to make it functional, to connect it with real data, not with dummy data. So yeah, if we look in our documentation, the GraphQL API is ready. And you can see, you can explore it here. You can see all the queries that we have. We can do like searching, like asking for recommendation, getting the track, authenticating, and so on. Rafael, hello, how are you doing? So I'm gonna go ahead and do a git add, git commit -m, track details query. So the next step for us is going to be to get this data in our React Native application using Apollo. So that's going to be the next step. Stay here. If you have any questions, feel free to ask. And I'm going to be back in 1 minute and we can continue. All right, so we are back. And we're going to continue. So as I was saying, our next step is going to be to query our newly created GraphQL API inside our React Native app and get the data. Yeah, get the data there. For that, there are a couple of options. There is Apollo client, there is React query, and some other libraries that you can use. However, in this tutorial, we're gonna use Apollo client. You can check the documentation of Apollo client here, but we're gonna take it step by step, and I'm gonna explain you everything we need to know about Apollo client in order to start interacting with our GraphQL API. Let's start by installing Apollo client and GraphQL inside our React Native project. So open up a terminal. This time, make sure you're not in StepZen folder. So you are in the root folder of your React Native project. Let's do clear and let's install Apollo client and GraphQL. While that is happening, we are going to define a new provider that will set up the Apollo client and will provide the client to the rest of the application, because the client should be available everywhere. So that's why it's a provider. So I'm gonna call it Apollo. How do they call it? Apollo client provider, client-provider.tsx. And here we're gonna have to set up Apollo client. First of all, let's import Apollo client from Apollo client. We're gonna start by defining the client, by initializing the client using new Apollo client. The Apollo client requires some configuration. One of them is the URI. Basically, what is the URL of your GraphQL endpoint? Our GraphQL, if you remember, it was a couple of minutes ago, we deployed it on StepZen. So if you cannot find the URL here, you can stop it and from the StepZen folder, run again StepZen start. Because after it's started, it will show you what? It will show you this URL at the top, HTTPS, and it should end with __GraphQL. Let's copy this URL from here and use it in our URI. The thing is that this URL contains your account name, it contains your endpoint name, and the rest is the same. Now that's our URI, but we also need some headers. We need some headers for the authorization against our GraphQL API itself, not against Spotify or something else, against our GraphQL. If we look in the dashboard of StepZen, we were able to interact with it because it automatically, for example, I don't know, not get token, but yeah, get track. We were able to interact with it because in the headers, it automatically had this API key using authorization. So that's why from our React Native application, we should also assign an authorization header to all the requests that will be made towards our GraphQL API. So the API key should also be somewhere here. You can see it. Yeah, we can get it from using StepZen itself. So we can do StepZen who am I -- API key. And StepZen will give you the API key of your API. So it should be API key space and the actual API key. What's going on here? Apollo client. Oh, yeah. And yeah, the URI headers. And lastly, we need to specify the cache. The cache is the way Apollo client will optimize and cache all the results locally. One of the ways we can do that is using a in-memory cache imported from Apollo client, and let's initialize it here as in-memory cache. That's it. Now our client is ready, and the next step is to make it available to our screens and components. To do that, we're gonna need a Apollo client provider component that will receive children from props with children, and what it will do is it will return a component imported from Apollo client, Apollo provider. So it will return Apollo provider. Inside of Apollo provider, it will render the children, but Apollo provider has a required property called client, and that's how we assign this newly generated client, and we make it available to our components. Props with children should be imported from React. Now simply export default this component, because we need to import it in our root layout to wrap it around everything else. So let's go to our source app underscore layout, and the same way as we wrapped our stack screens with player provider, we're gonna do that using import Apollo client provider from providers, then Apollo client provider. Now when you wrap providers inside our providers, you need to think about, should the Apollo provider be before the player provider or below the player provider? Well, it depends on who depends on which data. If the player provider depends on some Apollo client, in that case, the player provider should be lower, inside basically. And I think that's correct. Like the Apollo should be first, then the player. Okay, so now that we have this Apollo client provider, nothing changed, but in our stack screens, we're gonna be able to execute queries. So let's go ahead, and I think I'm gonna do a git add, git commit, set up Apollo client, and we can start with our first query. Our first query is going to happen on our home screen. So let's open tabs index.tsx. At this moment, the tracks are coming from our assets. What we want to do is we want to query our API. So as I said before, every time we're gonna need to implement a query, we first come back to the dashboard to design the query, to make sure that we can get the data that we need, and after that we can copy it there. I'm going to, I don't know, delete everything, and on the home screen, as I said, we want recommendations. For the genres, I don't know, we can say something here, I don't know, rock. And what do we need? From the seeds, we don't need anything. This is mostly information about the recommendation itself. About tracks, we will need ID, name, preview URL. What else? I think that's it. Then, about the artist, we will need ID, name. About the album, we will need ID, name, and images with their height and URL and width. And probably that's it. So now if we execute this query, we will see a list of data with information that we need. The data, like the fields that we selected here, should be exactly the fields that you need. For example, on the home screen, we might not need the image height and width. We might only need the URL. Or yeah, like it depends on the screen that you're building this for. So add the data that you need for making your user interface functional. And what we can do then, we can stop here for a moment. So if we're gonna do it like this, we see that the parameter seed genres is hard-coded. This way, we're not gonna be able to adjust and send different parameters here. That might be something that you want, but probably you would want to be able to send different variables here. To do that, we use this $sign and maybe genres variable. We define this variable on the my query itself. So we can do my query here, $sign genres is equal to a string. And I will also make it required to make sure that we always provide something. Now, if I'm gonna try to execute it again, it's not gonna work because we need to provide variables down below. Genres equal rock. And the benefit right now is that based on only variables, we can change what we are, what recommendations are we getting from, I don't know, drum and bass. Yes. So now that we have separated our data in variables, we can go ahead and copy this query that we defined. We can come back to our home screen, and let's start by defining this query at the top. Let's call it query, and we're going to define it using the GraphQL and then the backticks. We're going to paste here the query that we copied, and we need to make sure to import GraphQL from, I don't know why it's not imported automatically, but it should be imported from Apollo. From Apollo client. Yes. So yeah, const query equal always GraphQL and backticks, and then paste the query that you created in the dashboard. That's it. Now from Apollo client, we can import a hook called useQuery that will help us execute queries. It's pretty simple to do that. We're gonna call useQuery and we're gonna send the query itself. Besides the query, remember that we also have to send some variables. We can do that with Apollo client by sending the second parameter for the options and here specifying our variables. The variables will be an object, and if we see here, that's what we had. Genre, for example, drum and bass. Now, how do we get the data? Well, we get the data here in an object, and there are a lot of data there, but what we are interested in usually is three things. Is the data, is the loading indicator, and the error. Initially, when the application opens, there will be no data because the query just starts executing. In that situation, loading will be true. So we can check if loading, then return an activity indicator imported from React Native. That's going to be a spinner. So if I refresh the page, you should see the spinner for a couple of seconds, and only then we see the tracks. The thing is that the tracks are still from dummy data. Let's go ahead and do if error. We are going to, I don't know, return an error message or a text like failed to fetch recommendations. You can import it, I don't know, from themed, where is it? Or from React Native. But in that case, make sure to add a style here for the color. White. And lastly, we can look into our console log, into our data object, because if there is no loading and there is no error, that means that it successfully brought some data back in. So if we look at our result, we see that the data is an object with recommendations and with tracks. That's exactly the data that we will see here. So data has a recommendation and an array of tracks. To get it, we're gonna do const tracks equal data dot recommendations dot tracks, and we can access them safely because data might not be defined, recommendations might not be defined, and yeah, let's do it safely and default it to an empty string if there is some problems with our data. Now the tracks are coming from the API, and we can go ahead and remove dummy data tracks import at the top. So just like that, as you can see, these are songs from recommendation, and they are based on the genre drum and bass. We can already play them, and the player is still working because they have this preview URL. Some of them might not have a preview URL, but most of them do have. And you can have a look actually in the API here for the genres. You can send this request once, and you're gonna see all the available genres. For example, I don't know, house. And you can also add them with comma. For example, drum and bass and then house. And this way you can adjust how you can get the recommendations of a user. At this moment, we are still in a way hard coding the genres variable, even though we can change it from the code here. But what you can do is you can add a selector beforehand for the user to select like what he's interested in, and based on that selector, send it as a variable here. So that's also possible with the approach that we have here. So yeah, that's how we query our GraphQL API using Apollo client. From now on, all we have to do, like the steps we have to follow is, first of all, define the query that we need for a specific use case. To do that, we open the dashboard and we select the fields that we need for that screen. We test it, we send it, and we make sure that the variables that we are using are not hard-coded, but are actually coming from variables themselves. Because with these variables, we're going to be able, from our code, to send different data. Now, we copy the whole query from here. We put it between these GraphQL and backticks. And then using the hook useQuery, we execute that query, we send custom variables, and we get back information about the status of our query, whether it's loading, if it had an error, or if it has tracks. For example, I'm gonna do here ID 123, and this one should fail and return an error. I'm not sure if it's actually gonna do that. I think it doesn't throw the error, it returns it, so the error messages should be a bit different based on the data. But yeah, that's our queries. And we already have some data coming from the API. Now you can pause the video and try to implement the search query yourself, or we can do that together. So, should we do a commit right now? We can git add, git commit -m. Let's do recommendation query. Okay, recommendation query is done. For the next one, we have the search. The search is kind of the same, but it will only work based on the search field, right? So what we have to do is, first of all, let's open the search. Let's go to our dashboard. Let's go to our dashboard, and I'm going to remove this query, and let's try to add a search query using a Q here, I don't know, an F. And for the tracks, we're gonna have items, and here we're gonna have ID, name, and so on. In my case, I want to query the same data about the tracks themselves. So what I'm gonna do is I'm gonna look at the home screen, and inside these tracks, I'm gonna copy everything, including the album and artist, and I'm gonna replace it with these fields from the items. Now it should have the same fields that we had before, and if I do search, it works. The searching works. Go ahead and let's add the variable Q here with a string, and instead of an F, that's gonna be the variable. Now from variables I can say Q, maybe drum and bass. It didn't find anything. Maybe an F. Oh, I have a typo here. So that's good that we are doing everything in the dashboard first, and we have results. Okay, fine. We can copy the query. We can bring it back to our tabs search folder. And here, let's start by defining the query. Equal GraphQL, backticks, and then paste your query here. Make sure to import GraphQL. I don't know why it's not suggesting me to import, but it's imported from Apollo client. And besides that, we also need to import the use query. Now using this use query, we can go ahead and define here const use query, the query itself that we define above, and the variables will contain this Q query that will come from state. So here is where we are not hard coding the variable, but we are actually taking it from state based on what user is typing. Now we're gonna have data loading and error. I'm not gonna do the same strategy as on the index to check if loading return activity indicator, because in that case we are not even gonna see the text input. So what I'm gonna do is above a flat list, I can add here some conditionals like this. If loading, I will do and activity indicator. The same thing with if error is true, then render a text with failed to fetch tracks. Now the tracks in the flat list, let's define them here, will come from tracks, will come from data dot. We can look in the dashboard how to access it. Data.search.tracks.items. .search.tracks.items. And then I'm gonna add the question marks to access them safely. And if there is no data, it's gonna be an empty array. Now I can safely remove the tracks imported from the dummy data, and we can go to the search and see if it works. For example, if I search NF here, we see all the songs from NF. I don't think we have previews, mostly not all of them, but if you search for something else, you're gonna be able to play them from search as well. So just like that, yes, you can search here, drum, go drum, and so on. So go ahead and play with this and see how it works. But yeah, that's our search query implemented as well. So let's do git commit, git add, search query in our application. Oh, that was interesting. So the last feature from today is a custom feature to save favorite songs. And by implementing that one, I want to show you how you can add and connect different data sources to your StepZen GraphQL. Because for now we showed like how to interact with Spotify API, but in a lot of projects that you're doing, if you are consuming a public API, you most probably have some other data sources. Or a different use case would be to connect different public APIs. A good example would be to connect Spotify API with the Google Knowledge API, Knowledge Graph, and the Knowledge Graph can provide us more information about the track, about the artist, tracks, and so on. So that would be one approach where you would need data from different sources. Another one would be, in a lot of cases, when you develop custom features, you have to save this data in a database somewhere in your API. So that's what is going to be the goal of the next feature that we are going to implement. And this is going to be our possibility to save songs in our favorite lists. Not in Spotify favorites or Spotify playlist, but in our application. So with this feature can be extended to different use cases as well, like creating custom playlists or others. But yeah, it's gonna show you how you can connect directly to a Postgres database and how you can manage your data there. When it comes to the database, StepZen can help you connect with SQL databases such as MySQL, PostgreSQL, with MongoDB as well, and other databases. What I'm gonna do is I'm gonna use a PostgreSQL, which is a very scalable and powerful SQL relational database, and we're gonna use neon.tech to host for free our PostgreSQL. There are multiple ways how you can host a PostgreSQL. You can do it locally, you can do it on AWS, but I believe that the easiest one, I looked at different solutions and I found that the easiest one was neon.tech, and they also offer some free trial for one project, and it's good to get started. So go ahead and sign in. You can sign in with GitHub as well. And I already have here a test database, but I'm gonna delete it because I think we only have one for free. So let's go ahead and create this database here by creating a project. The name will be, I don't know, Spotify clone. Let's click create project. And just like that, we have a PostgreSQL ready for us to connect and to save data in the database, to read it and so on. The problem is that we still don't have any tables. If we look at the tables, they are 0. Let's go and create a table using the SQL editor. And you don't have to know a lot of SQL for this. You can actually use ChatGPT by describing like how the data should look, and ChatGPT will simply give you the create command. For now, go ahead and copy the create command from our guide. That will create a table with 3 fields: ID, user ID, and track ID. This will specify that a user with this ID liked this song. And with this table, we will be, if I run it, error at track ID. What did I do? Track ID. Track ID. Why is there an error? syntax error, track ID. Should it be lowercase ID? I don't believe so. Run. Request completed successfully. Maybe. Yeah, I think so. So I'm gonna update in your documentation as well with track ID lowercase. And now if we look at the tables, we should see one table with no data yet. It's not a problem. We will add it in a moment. But yeah, basically the table is there. It's ready to connect with it. Now the fun part, and back to the StepZen magic command import. So by simply executing this command StepZen import PostgreSQL, StepZen will parse, introspect, and create the GraphQL queries and mutations and types, models necessary for us to interact with our Postgres database. Let's see how it works in action. I'm gonna go ahead and navigate to StepZen directory. Make sure you're there. And let's copy this StepZen import PostgreSQL command that will help us import and help us import the Postgres. No, help us build the GraphQL API on top of our PostgreSQL database. Now it asks us what is our host. Let's go back to our neon, how to pronounce it? I'm already tired. Dashboard, and here we can see the connection details. The connection details, I don't know exactly what's the best way to check it, but for example, if we switch to Next.js, we're gonna see here the host, everything separated by things. So let's go ahead and copy this host from here, come back and paste it in the first question. What is your host? What is your username? Let's go back. User, this is the user. What is your password? The password should be this one, but it's not visible here. So I'm gonna move back to the first option, PSQL, and here is the password hidden. I'm gonna click on it, it's gonna become visible. I'm gonna copy it, everything from the double dots till the @ sign. So copy the password, paste it here. Database name is the last part, and it should be NeonDB. The schema, we can leave it blank, enter, and here we can say no, enter, and we see successfully imported. If all the questions from here for the host, password, and how to connect to our database was specified correctly, StepZen should have successfully generated our GraphQL API based on this, on that. Let's have a look at the StepZen PostgreSQL folder that was just generated. And we see here a new type, favorite with track ID, with user ID. We see some predefined queries that will help us get data from that table. And it's quite a lot of them, like the list, the paginated list, the favorites by track ID and user ID, and so on. And also some examples of mutations. Not examples of mutations, but also some mutations that we can use. And if we need additional ones, we can copy paste. We can define different SQL queries for some custom queries. Anyway, what are we interested in? I think we can start with looking at the dashboard. Let's look at our StepZen dashboard. Let's refresh and see. I'm going to delete it from here and see what new queries we have here. Let's open builder. We see that we have favorites list, favorites by track ID, favorites paginated list. But what we're first interested in is not in a query, but select from here a mutation, add plus, and we're gonna see here delete favorites and insert favorites. With insert favorites, we need to provide the user ID, for example, Vadim, and the track ID 123. And if we request back these fields, execute it, we see the result. And if we go back to our Neon console, to our tables, we should see favorites with the data that we just provided. Vadim liked the track ID with ID 123. And you can add multiple things here, 4, 5, 6, and so on, or here, I don't know, Alex, 7, 8, 9. So you're gonna see all of these rows in our database. Favorites, here they are. So let's go ahead and this mutation that we defined here, let's implement it in our application. First of all, remember we need to move from hard-coded strings to user ID. Here I can use like a different string, a different case, like with uppercase, camel case. That's user ID, and the second one is track ID is a string. So the user ID goes instead of this string, and the track ID goes instead of this one. Now let's copy this mutation and let's go ahead in our project. And when will we add things to favorites? We will do that whenever we press on this like icon. So the like icon is in our components player. So let's go ahead here in the player. And what we're gonna do is we're gonna define the create favorite or insert favorite mutation equal to GraphQL backticks and then the mutation that we created there. Let's import the GraphQL from Apollo client. Besides, stop please. Besides the GraphQL, we also will import a use mutation this time, not a use query. A use mutation. So in GraphQL there are two main operations: a query that we use to get data from a server, and a mutation that we use to update information on the server, either inserting, updating, or deleting. So in this case, we want to insert a favorite track, so that's why we have to use a mutation. Let's go ahead and start defining this mutation here using use mutation. The query itself will be insert favorite mutation, and at this moment we will not provide any variables because the variable will depend on the track, so will depend on the moment when the user presses the like button. So the mutation, in comparison with a query, the query is executed as soon as the component mounts. A mutation, on the other hand, will not execute right away, but it will return us a function that we can call and trigger the execution. So this is going to be insert favorite. So this is the first thing that it returns, and the second one will be the same object with data, error, and loading. I'm not gonna need them because I can use the insert favorite. And I don't know, where do we have the icon? On play pause, but the heart outline should be on press on like. Let's just one like this. Const on like is going to be probably a sync. And let's call the insert favorite. But here we need to provide the variables. And what variables do we need to provide? We need two variables, the user ID and the track ID. For the user ID, I'm gonna use for now like a hard-coded like Vadim user ID, and for the track ID, I'm gonna use the active track ID. But it can be null, so that's why we will check here if track is undefined, we're gonna return, otherwise we're gonna insert the favorite. Now if I press on this one and press like, nothing happens, but we can look in our database to see if something was added here. And if we look in the favorites, yes, Vadim has liked a track with a proper ID now. Perfect. So that means that we are correctly adding things to our database in terms of favorites, right? Now we want to query back to see if a track is favorite or not for a specific user in order to change how we are rendering this icon. To do that, let's see if we have already a query for that. So in the query, there is favorites by track ID. There is favorites by track ID and user ID. I think that's what I want. So I don't know, 1, 2, 3, Vadim, and this is going to be ID, track, and user ID. That gives us the option, but if I do here something that doesn't exist, it's gonna be an empty array. That's good. Because we can use this one with some variables here, track ID, string, and user ID string. Let's put it here instead of this track ID, this user ID. And I'm gonna use this query let's define it at the top here. Const is favorite query equal to GraphQL, and here we can define the query. Now let's execute it at the top of a file. Use query. And a query is executed right away, so we need to send variables. No, the first option is the query itself is favorite query. We need to make sure to import the use query from Apollo client. And to pass their variables. The variables is user ID Vadim, and track ID will be track.id, or I don't know, empty string, because if it's null, empty string. Now we're gonna get back the data, and the data will contain what? The data will contain favorites by track ID and user, and we can understand if the track is liked or not, is liked, based on the data dot favorites by track ID dot length. If it's more than 0, that means there is a track liked by that user. So using this is liked, we can go at the icon and we can change what icon we are displaying. So if it's like, it's going to be heart, otherwise heart outlined. So if I select the first one, and if I like it, will it change? For example, let's search for a very specific song. I don't know, When I Grow Up. The first one, NF, When I Grow Up. I'm gonna like it. And let's do refresh. I'm not sure what's happening there. When I Grow Up. First one. Doesn't work, is liked. User ID. Oh, here should be track ID. Made a mistake. And it's working. So if I look at different ones, it's not liked. But if I come back here, it says that it's liked. Perfect, perfect, perfect. Amazing. So we are correctly adding is liked, and I think it should also update it, right? Or no? Data. This is liked, can be refetched. So I can do like if track changes, I can also refetch that one. So now if I'm gonna do, no, I can refetch when we add a like. So on like, await, and after that refetch. So now if I'm gonna go ahead here and do like, it updates. Perfect. So that's how we add likes. Now let's have a look at how we can remove likes. Removing the likes. If we look in the mutations, plus, we see delete favorites, and we can specify here ID, track ID, and user ID. Let's look in our StepZen, Postgres SQL, and what do we have? Delete favorites. Why it has all of them? I don't know. What if I delete the track ID here and only leave the user ID and the ID? Will it still work? Let's see. If I delete them from here. Let's see if the StepZen is still working. StepZen is still working. The mutation. Why it has ID and track ID? Oh. I removed the track ID, but I wanted to remove ID. I don't care about the ID. I want to only I know the track ID and the user ID. So let's see if it will work. So it doesn't have an ID, but it has track ID and user ID. So if I'm gonna go here and say that I want to remove the track liked by Alex with 789 ID, will that work? Track ID 789 Alex, and if I execute, it found it, but I'm not sure if it deleted it. So if I refresh, I hope, yes, it deleted. It worked. Amazing. So that means that we can copy this query from here. Make sure to add that track ID as string and user ID as string. And let's take it from here in our player.tsx. Let's add here a new mutation, remove favorite mutation equal GraphQL and the mutation itself. Now we can duplicate this insert mutation again and do the remove favorite mutation, and the name will be remove. Now when we press on this like button, we call this function onLike. Here we need to check if is liked, we want to remove, otherwise we want to insert. So if it's liked, I want to call the remove favorite with these variables. Otherwise I want to insert. So this way we can remove favorite by pressing again. And it works. When I grow up, I'm gonna remove it. I'm gonna refresh the application. I'm gonna go to search and search again when I grow up. I'm gonna look at the first one and it's not liked. If I like it, it updates. Perfect. So far we saw how we can add data to our Postgres database, how we can read it, and how we can remove it. Now let's go ahead on the favorites page and render a list, query the list of favorite songs, because this one comes with these challenges and I want to show you how you can implement that. First of all, what we're gonna do is go ahead, open the tabs favorites, and here we have a list of tracks. Let's go ahead and see how we can get a list of tracks with all the data that we need about them from our GraphQL endpoint. So we see a couple of queries here. Favorites by track ID. No, favorites by track ID and user ID. No, favorites list. What I want is favorites by user ID. I want to query all the favorite songs for my user. So let's go ahead and StepZen in the Postgres index, and in the queries, see how we can change some of the queries to have that one. Because, for example, favorite list will give us all the favorite. Here by track ID and user ID, I want only the user ID. So I think we can simply copy this one, update the name to not have track ID. It doesn't work by name, but still, we need the descriptive name. Favorites by user ID. It works based on the properties that we send. So user ID is going to be a string, and the table and configuration, everything remains the same. So now we have a query, favorites by user ID, that should appear here after a refresh. Favorites by user ID, and if I say here Alex and take ID and so on, and if I execute it, we are not going to have any favorites, but if I do Vadim, we're going to have a few of them, because that's what we have in our database, the user ID and all the track IDs. The thing is that the response from this favorites table contains only these three fields: ID, track ID, and user ID. But on the screen favorites, we need not only the track ID, but we also need the track name, the artist name, the album name, and so on. So what I am interested in here is to have the track name to be able to query it like this. But we see that there is no track field on the favorites type. There is only these three. And if we would have to query once for a list of favorites and then for every single favorite item to go ahead and get the details about a track manually, we get back to the square one where we are underfetching data and we have this n+1 problem. The n+1 problem is that if we have a list of 10 songs, we're going to execute 11 queries. One for getting the list of favorites, and then for every single item in the list, which are 10 items, we're going to have to execute one more query. Well, that's not the point of GraphQL. That's what GraphQL comes here to help us. And with StepZen, we can connect types with different queries and with other models from our API in a way that it will automatically behind the scenes be mapped together into one single graph query. At this moment, like, the favorites is very separate from everything else that is related to our track and so on. For example, in the track index here, we have a query that, knowing the track ID, can get you the details for that track. So what we want to do is to link the favorite type with the, with a track type, this one, track response, that will include album, artist, and so on, by executing the getTrack query. How do we do that? We are using a new directive called materializer. So first things first, let's define a new field on the favorites here. The field is going to be called track. The type of that field is the type of the response of our query. So if we're going to execute the getTrack, the response is track response. So response, track response. And with materializer, we're going to specify how do we want to get this track here, track information here. Yes, that's correct. So in the materializer, we can specify the query that we want to execute, and the query will be getTrack. And it will also need an array, a list of arguments, because the getTrack, which should use this kind of codes, because getTrack expects a track ID. So we can specify that the arguments will be name, track ID, should come from here with the same capitalization, and where do we take this track ID to receive the details about the information? We take from the other fields of this favorite, basically from our database, as this track ID. So track ID, not track. And the field is going to be track ID. And just like that, let's double check that our API is deployed. We can go back. And if I'm going to execute it one more time, this track query should be there. It says null. It says null. Yeah, I know why. So now we see that when querying the favorites by user ID or any other query that will return a favorite type, besides the information as ID, track ID, and user ID, we also have now the track information. And we can take the name, ID, artist, album, and so on. So if I'm going to do that, for the first favorite, the track is null because the ID was a dummy ID 1, 2, 3, the second one as well. But for the later one that I added through the application, now we see that it actually has information about the track, based only on the ID that we saved in the database. And StepZen behind the scenes went ahead and gave us this track information by executing the get track query and optimizing it and caching it on their side. So this way it's optimal, and from our front end, now we can send only one request to get the information on this screen of favorites. So let's go ahead and implement that in the application tabs favorites. I need here a variable user ID string, and it's gonna come here. And for the track information, I'm gonna take it from, for example, index. Inside tracks, there is ID. I'm gonna copy the fields ID, including artist and album, and I'm gonna paste it inside the track here. User ID is undefined. We can add it here. Yes, and it works. So now we can copy this query. I don't know why it's called get token, but should be get favorites. Doesn't really matter, but let's try to keep it clean. Now back in our favorites page, let's import GraphQL and use query from Apollo client and start by defining the query GraphQL, and this is the query, and we can query it inside our component data loading error, use query, and we need the variables for our user ID, should be Vadim. Now if loading, I will return the activity indicator. You can also implement the error messages, but I'm gonna go ahead and get the const tracks equal data dot, let's look in the dashboard, data dot favorites by user ID, favorites by user ID, and it's actually not going to work, and I'm gonna explain you in a moment why. If I go to the favorites, because we can console log data and see what do we have here. If I go to the favorites, but of undefined, yeah, it should be question mark, and it's still undefined. Why? If error, let's do console log error. Oh, come on. Favorites tab, data. Why it's not console logging? Do you have any typos or something? GraphQL query get favorites user ID. User ID. Variables. What's happening here? If I remove a track, kind of works. Why is it in dashboard working? Maybe I have to refresh for some reason. So here it's working. It's returning. Oh, no. At the end there is a bad request. Favorites by user ID 1. Maybe it's the problem with this 1, 2, 3, and 4, 5, 6. So I'm gonna go in the SQL editor and I'm gonna do a new query. Delete from favorites where ID equal 1 and where ID equal 2. Will that work? Favorites. Okay. And if I execute it right now, it doesn't have any bad request anymore, so it should work perfectly fine. In favorites, yes, we see favorites with information and track information and so on. Perfect. Now, as I said, let's take the information about tracks there. But as we can see in our response, the array here does not contain information about tracks. It contains information about favorite tracks, which will link to a track. So what I want to do is I want to map from this structure to a favorite to only include the favorite.track. Favorites by user ID or that. Okay. And should be there. If I go to favorites, yes, it's here. So now if I'm gonna search for something, happy, and if I'm gonna add it to favorites, if I'm gonna go to favorites, we should see it somewhere here. Might not be right away, but it's gonna get here. So happy, I can remove it. And when I grow up, I can remove it. We can implement like the fact that it's not updating like right away. It's a problem with Apollo. But the thing is that everything is actually working. So we can add, remove things from there, and everything is going to be saved in our custom built database. So none of them have a preview. Alright guys, so that was everything that I have prepared for you today. It was a super long one, but I hope that you learned a lot. We covered so many things and a very wide variety of things for helping you build full stack mobile applications. We started with our mobile application that we built in React Native and Expo. We use Expo router for the navigation. And after that, for the music player that we created, we defined we used Expo AV to play music, and everything is actually working properly. After that, we worked on the backend. We learned about the Spotify API and how we can work with it. And using StepZen, we created a GraphQL API on top of that. That helps us easier query the information in our application and specifically the information that we need. After that, we also implemented some custom features using a PostgreSQL database. We connected it as well to our StepZen API, and this way from our React Native application, we don't have to think about where is the data coming from. All the data is going to be governed here in StepZen, and we have to integrate only with one endpoint. Using some cool directives from StepZen, such as materializer, we were able to connect different data types, different queries, and also we saw something interesting as well, the sequence directive that helps us run multiple queries one after each other. With that being said, we finished our Spotify clone. You can see a list of recommendations, you can search, and everything works. It's gonna work with Spotify API. You can favorite songs and they will appear in your list of favorites here. And I encourage you not to stop here. Try to implement some extra features because there is a lot of things that you can do. For example, starting from the home screen, here we're working with a recommendation algorithm. What you can do actually is, where is the VS Code? In the index, as you can see, there is a property, a way to select recommended genres. What we are doing, wait, it's not this one. Index. So at this moment we are hard coding the genres, but what you can do is, for example, in this model screen, you can render a list of pre-existing genres that the person can pre-select, and based on this list to generate the recommendations. Another thing that you can improve on the home screen is not only to recommend tracks, but also albums or playlists. And that's the same for the search, because the Spotify API for the search will give you back different things that you request. For example, artists, tracks, episodes, audiobooks, shows, and so on. And you can query them all at the same time. And when you use StepZen import, StepZen will automatically parse the other different types as well. So you can add multiple tabs here that after you search something, you can select what you're searching for. For favorites, you can use the same logic here to create playlists. And when you might have a plus button here in the player that when pressed will open some kind of a model from where you can select the playlist and you can save your information to the playlist. The favorites at the moment is also working with a hard-coded user ID, so that would imply that your application will also have some kind of authentication to differentiate between users. I kept it simple, not to overcomplicate it with this, but you can do that as well. So yeah, there is a lot of things that you can do on your own, and by doing that to learn much more that you could learn in the last 4 hours. Anyway, I hope you enjoyed this one. If you did, make sure to subscribe to the channel because 99% of you guys watching this are not subscribed. So if you are part of a 1% club, which means that you also reach till the end of the video, when my voice is cracking and I cannot speak anymore, make sure to leave a comment, part of a 1% gang, subscribe to the channel, and I will see you very soon with more fire content like this. So yeah, catch you soon, guys. Bye bye. And thank you very much, StepZen, for helping us.